Dr. Meenakshi Singh Madam, Dr. Royali Sanyal Madam, it's my immense pleasure to welcome you all at International Conference on Horticulture Research Team, Horticulture, Technical Innovation and Future Farming. We are deeply honored to share that the Amity Institute of Horticulture Studies and Research, in collaboration with Amity Institute of Organic Agriculture, under the aegis of Amity Food and Agriculture Foundation, is organizing this prestigious conference at an international level in hybrid mode, bringing together eminent scientists, academicians across the globe. With us, our founder President Ashok Chauhan, sir, whose relentless dedication and pioneering vision have led this very foundation of our Amity University. I would like to express my profound gratitude and respect to Chancellor Dr. Chauhan, whose dynamic leadership continues to elevate Amity to global excellence, and our Honorable Vice Chancellor, Professor Dr. Balash Madam, who vote inspires every day. Would also retain sincere respect to W. Selvamusa, Committee on Technology and Innovation Foundation, for his visionary guidance and invaluable contributions to innovation. I'd like to acknowledge Dr. Nutan Kaushik Madam, Director of the Foundation, for the vision and immense in shaping this conference into a reality. With all these blessings, and it is now my pleasure to officially commence the third International Conference on Agriculture Research, ICRAHOR 2026, and an Sunday of Knowledge and Innovation. Approach with the inaugural session. May I request Salamuti to candidate our digital office. I request Dr. Madam to felicitate Mr. Kamal Kumar sir. In India, addition to also speaking is marked by seeing events, the more lighting of the and spread and the note, let us begin blessings of Maswati. I request our esteemed dignitaries on the dais to continue with the lighting of lamp or Saraswati Vandana.
शंकर प्रभृतिभिः वन्दिता रामपातु सरस्वती भगवती निशेषजाडपाः शुक्लां भजाय सारपरा बुद्धिप्रदां शारदा.
Now, to commence, I invite Dr. Nutan Kaushik Madam, Director General, Amity Food and Agriculture Foundation, and Director, Amity Institute of Horticulture Studies and Research, to deliver the welcome note.
Good afternoon to everyone. Respected Honorable Founder President, sir, Honorable Chancellor, sir, Honorable Vice Chancellor, Madam, Dr. Silvamurthy, sir, our distinguished guest, Dr. Meenakshi Singh, sir, Dr. Prabhat Kumar, who has joined online, Kamalji, and Mr. Harris, and all the distinguished speakers, delegates, and dear students. It's my great privilege to welcome you all to the third International Conference on Horticulture, Recent Advances in Horticulture Studies. Actually, this is third in series. Previously, we organized two more conferences. We started in 2022, and after every 2 years, we are organizing one conference. So this is the third in series. First was in 2022, and second was in 2024, and this is third in now in 2026. So for the fourth one, we will be having in 2028 now. So we are happy that the series which we started in 2022 is taking now shape. We started with a small beginning, and now we are going into. We are still maintaining this. It's rather growing little bit. So we see that there will be great change in 2028. We see a much bigger celebration in 2028. So, being a small institute offering only masters in horticulture and that too in post-harvest technology, we are collaborating with the Amity Institute of Organic Agriculture, AIOA, and with the under the aegis of Amity Food and Agriculture Foundation. So we all together are celebrating the research which we are doing and the education which we are imparting in the field of horticulture, particularly the post-harvest technology. So the concept started with the feeling that our students, our faculty must discuss their research, whatever they are doing, with the experts which are in different fields, and they should get to expose to the recent advances which is happening in this particular field, so that they can, and they also get the opportunity to interact with those higher experts and get to and develop their own network and get and learn from from the experts which will deliver the lectures. Apart from that, for last 2 years, we are also been organizing this entrepreneurship, these competitions, where students are able to present their ideas, for the startup ideas. And this year also we had organized just before the inaugural session, and we had two esteemed judges, Professor Dubey and Professor Thapar, who had actually provided a lot of good ideas and mentorship, and the ideas which were presented by 8 students of our master's courses and one PhD scholar. So by this meaning, so we are not only imparting the education, but we are imbibing the culture of innovation, innovative ideas. So so whatever they are learning, they are our basic aim is to bring the students it's experiential learning. So in the classroom also, we do not have a fixed lecture kind of things. We only have the lecture, the practicals. Practicals are fixed, like they will learn some extraction, utilization of the waste. But it's not that same year they are extracting from the same waste. Every batch is extracting from the same waste every year. So a student, they identify the idea. In every practical class, we like ask the student, we do the brainstorming, they decide which ways they will work on. They are taken to the, what you call, at the ground, wherever the waste is created, they go visit the site, and then they identify which is the potential idea, which is the potential waste where they can work on. And then during the practicals, they do the utilization of that waste. That's a waste utilization course. Another course is on the floriculture, like floral decorations and so on. There also they go and then they develop these products from the flowers based on the learnings which they have taken in the theory. So it's an experiential learning. So it's a case-based study. So not keeping the fixed practical structure, keep them the flexibility of doing the practicals on whatever they learn and relevant to the society. And this entrepreneurship session which we had is the result of that particular one only. Because the students get the only idea when they are exposed to the real world problems. So this through this conference, we have been very fortunate that around 20 speakers, eminent speakers, have agreed to give the keynote or the invited lectures, apart from the oral presentation and the poster presentations. So we are very fortunate. Out of those 20 speakers, around 15 are international speakers. Though they are joining online, some of them were supposed to join offline, but because of the recent Iran war, they had to cancel their trip. So everyone now, all the speakers which are international are joining online. So I welcome you all. I thank all the speakers who have accepted our invitation and to share their knowledge base, because each speakers bring different experience. They are expert in their own field. So whatever they have, their 30 years, 25 years, 20 years experience, we are bringing here at this platform for the benefit of the faculty and the students and the researchers who are engaged in this field. And I expect that at the end of the conference, that you generate new ideas of new ideas for not only for your academics but also for research, innovation, and develop your own networking. This is the basic objective of organizing the conference. And then at the end, we also develop collaborations with the people who are gathered over here. So I would like to say that horticulture is a very important subject, though, and post-harvest losses are very important. So this conference makes sure that we understand post-harvest losses and how So likewise, we have developed many products for functional foods. Yeah, I think some of you have seen during the presentation how they are developing the different kind of functional foods. And so Amity has been like a right in 2005 we started this agriculture domain here, though no private university started very recently, but MIT since its inception has the agriculture as one of the key key academic institution where we are imparting education in BSc agriculture, BSc honors agriculture, MSc agronomy, MBA agribusiness, and MSc post harvest technology, horticulture post harvest technology. And I'm very proud to say that last year we participated in IRF ranking, and MIT was ranked number 15 among all the 100 institutions across India. So we are very proud of that. That's because of our research and innovation, mainly because of the research and innovation and the academic settings which we have, the kind of innovative teaching we have over here. So I'm very happy, and students are very fortunate that we. So by this conference, I would like to thank each one of you who are participating, not only the faculty, the speakers, the distinguished guests which we have, but also the students because for their enthusiasm and for their participation. I'm happy that we have more than 100 presentations to be presented during this conference in various forms as keynote, invited lectures, oral or poster presentations. And I believe and I expect that a great outcome of this conference. Our Honorable Founder President said, I need 100% outcome of uh, every thing which we do, not only event or anything, but he needs 100% outcome. So I urge each one of you, especially my faculty and the students, that please make sure that we get the 100% outcome of this particular event. So with these words, I would again thank all of you. I'd like to thank Dr. Silvamurthy sir also. He's very busy here, but he has been able to accommodate our request to be here with us. Dr. Prabhat Kumar ji, he's currently sitting with the minister, but he's available online just to on our request that he wants to he so that shows how important this subject is and how people give priority to address our students. So thank you, Dr. Prabhat Kumar, for joining online. Dr. Meenakshi for coming over here all the way from Greater Noida, and requesting Mr. Kamalji has been our great friend and supporter for not only now, but since I think I know him for last 30 years, and we have been working together. And I'm fortunate that after moving to MIT also, we are continuing our friendship. So thank you so much, Kamalji, for your support, particularly Dhanika, RJ Agrawalji. RJ Agrawalji was wanted to join today, but he's busy with some other engagements. So he said he will be joining, he will be sending some more. And agriculture today also, Mr. Harris, he will be joining soon. And all those who have come over here, thank you so much. And I will not take much time because time is very precious. And we have to listen so many distinguished speakers which are lining up. So thank you. I once again welcome you all for this international conference. And I will request each students, please feel free to put up as many questions as possible to the presenters, because that's the way you can like open up your mind and then learn much better. Thank you so much.
Thank you, ma'am, for your warm and inspiring words. I now invite Dr. W. Selvamurthy, sir, President, Amity Science, Technology and Innovation Foundation and Chancellor, Amity University, Chhattisgarh, to deliver the introductory remarks.
Very good morning to every one of you. Honorable Founder President, Dr. Ashok Chauhanji, who is observing the program from his office. Parallelly, he is also attending in Amity University Lucknow campus. There is an activity in agriculture. So he just talked to me a few minutes ago. He conveyed his best wishes, blessings to all of you, all of us, for the successful deliberations, fruitful outcome. Thank you, Founder President, for your keen interest, dedication, commitment to the research in agriculture, particularly in horticulture, as agriculture is very close to your heart. And I am sure the deliberations of this conference will also add value, and we will give you the outcome as was mentioned by Dr. Nutan Kaushik. Chancellor Dr. Atul Chauhan and Dr. Asim Chauhan, both of them are also there attending that Lucknow campus, where there is a big event there happening in agriculture sector. So we thank you for your support, patronage, and complete the involvement in Amity research and innovation ecosystem. Now, I would like to express our gratitudes to our guests on the dais, particularly Dr. Meenakshi Singh, CSIR, and she has been a part of CSIR for a very long time, particularly in senior appointments, coming from CFTRI, from Mysore, and then coming to headquarters. She did a lot of work in the CSIR, and she helped us in terms of arranging many steering committee meetings. As you know, there is a MOU between CSIR and Amity Group. So there is all CSIR labs and all Amity institutions and universities work together under this umbrella of MOU. So we have a joint steering committee which steers the outcome from these MOU. So Dr. Meenakshi Singh was instrumental in spearheading, steering the outcome from this MOU, and particularly talking to the CSIR labs, directors. So we have a very fruitful collaboration. Thank you, Meenakshi. And now we look forward to continue our interaction with you. And she just told me that she is going to shift to Greater Noida, and we'll proximally she will be located, so we'll interact more closely with you. And Mr. Kamal Kumarji has been a part of our Amity, because every time he is here, it gives a lot of inspiration, motivation to us. And thank you for your support, guidance, and patronage you give to Amity University. I must say a few words about Dr. Nutan Kaushik, because this is a great lady whom we brought from Terry maybe 10 years ago. And she has done so much work, contribution to the nation. And when she was in Terry, she has steered the agriculture, food sector, biotechnology, and biofertilizers, biopesticides, in all the domains she has contributed. So we are fortunate to have her as the Director General of the Amity Food and Agriculture Foundation, and giving a lot of impetus to research in agriculture. Thank you, Dr. Nutan, for arranging this type of international conference. Like we have Dr. Doeli Sanyal, who is the Director of Amity Institute of Organic Agriculture. Again, she has a very rich experience. Terry, she is also from Terry, and maybe the Nutan Kaushik has attracted to bring also Dr. Sanyal. So thank you so much for heading this very important institution, organic agriculture, and all the brilliant faculties who are sitting here from the Food and Agricultural Foundation. And thank you so much for arranging this type of event, because the country is now in a new paradigm. Our Honorable Prime Minister Shri Narendra Modi ji has given a new vision to our country. India should become a developed nation, Viksit Bharat, by 2047, which is not very far. So in which this 1.42 billion people have to be fed properly because the health of the people depends one primarily on the food. So how do you keep them fit, productive, constructive, and also delivering to the best of their ability? Food plays a very important role. India was, when I was student in a school, studying in the school or a college, it was a begging bowl, looking for food to come from another country. Because we had at that time population was only 30 crores, but today it's 142 crores. But we have a big challenge. Population, the food demand is growing in terms of population. Middle class strata who can afford to pay higher food, higher quality food, and which is costly sometimes. So the affordability to have good access to food and nutrition security is also growing. Middle class strata. So now the cultivable land is dwindling down. So that is where horticulture, cereals, pulses, sugarcane, medicinal plants, everything, floriculture, everything, it's a big challenge. How do you, salinity of the soil, alkalinity of soil health is a major problem today. And the climate change is looming large, looking at us. So all these are challenges which we need to address as scientists, as Homo sapiens, and with Indian intellect, we find solution to every problem, more than one solution. So I think this conference should also lead to how do we meet these emerging challenges and the present challenges. So that is what you should discuss. And because this horticulture in the agriculture sector plays a very, very important role. Horticulture will include vegetables, fruits, floriculture. All this will come under the horticulture. So in this, how do we increase the value? How do you improve the productivity per hectare? So all this you should deliberate. And also how do you do the post-harvest? How do you do the value addition to the product when you are putting it into the market? So look at the complete supply chain, value chain, rather than only focusing on productivity of horticulture. Post harvest is very important. Otherwise, we lose, being a tropical country, almost 20 to 30, even sometimes 40% in some produces, like tomatoes, for example, because highly perishable vegetables. So that is where you should have innovative ideas. How do you manage the produce in the post harvest level? So these are challenges which I am sure you will address. And this Amity University, the Food and Agriculture Foundation, which has so many institutes, including Amity Institute of Horticulture Studies and Research, and we have a Institute of Organic Agriculture, Institute of Food. We have a separate food technology group, and we also have post-harvest center, which is international center. So we have everything, all the structure which is required. Then we also made a document, which is Amity Agri Vision, what we need to do in the next 20 years, where we brought agricultural specialists from outside and from within the Amity group. Then we formulated a vision document that what we need to do by 2035, up to that period, how do you align Amity Agri Vision to the national Agri Vision? So all this document, please look at this, so that we have given many solutions there, because we brought many experts from outside, even from ICAR and so on. And the other thing is we have a very strong MOU with Indian Council of Agriculture Research. That is another important, not only CSIR. ICAR, last about 10 years, we have a very productive and the MOU, which is now producing number of collaborative research, joint PhD mentoring, joint publication, joint patents. Everything is coming out of this. So ICAR, horticulture division is very strong there. So we should now expand. I will tell Dr. Nutan Kaushik and also Dr. Doyeni, Doyeli, that we should now look at how do we expand this, get the best outcome from these ICAR MOU. Please make some plans I like to discuss with you. So now coming to what Amity is doing in this area. Nutan just showed a tip of the iceberg. So I thought I will elaborate, because this is Amity is doing a wonderful job and contributing to this sector, because this sector is very important. 15 to 18% GDP, Indian GDP, comes from agriculture sector. 50 to 55% of people are employed directly or indirectly in agriculture sector and food. So that means this sector is very important. So many people are working in this area in India, and then also so GDP 15 to 18% is huge. So that is why this sector is important. And so how do we strengthen this? What Amity is doing in this area? What Amity is doing, if you look at the merit list of India, we are in top 3 or top 5 in many of the produce. Milk, number 1 in the world. And horticulture, we are number 2, sometimes goes to 3. And so we are number 2 position, vegetables, fruits, and we are number 2. And then similarly, fishiculture, poultry, everything put together, milk, I have already mentioned. So we are in top 3 position. But then, if you look at the productivity, this is production because we have large number of animals, large areas for agricultural land. So, in terms of production, we are good. But where we lack is productivity per hectare or productivity per capita. If you talk about the animal or a bird, so this is where we need to focus. Amity research focuses exactly on that. What we are doing, we have developed a root endophyte, which is known as Piriforma spora indica, which we have termed as root tonic. And this gives protection against the abiotic stress, low water availability, high temperature, low temperature, salinity of the soil, alkalinity of the soil. All this abiotic stress tolerance increases. Thereby, the yield increases. We have found in cereals, pulses, horticulture produce, including horticulture, and sugarcane, medicinal plants, everywhere this works. And we have done it in different agroclimatic zones also. So this is very, very useful. So Amity has produced a wonderful magical root endophyte, which is Piriforma spora indica. The second is we have now come into consortium, not only Piriforma spora, we have now gone into HNB9. This is another formulation which we have produced, which is also Teluromyces, and we have developed a biofertilizer. We don't call it as mycorrhiza or we call it as a biofertilizer because it grows, it promotes plant growth. So that is why we call it as a biofertilizer. So this one also has now the consortium has been working very well to increase the productivity. Now, having produced this, how do you store it? So she mentioned about zero energy cooling chamber, which is because most of our farmers are small and marginal. 90% of our total farmers is small and marginal, maybe 1 acre, 2 acres, 3 acres. So, how do you give frugal solutions, frugal innovations to our farmers? That has been the mandate of Amity. So, zero energy cooling chamber where there is no electricity, you just only have to keep a bucket of water and then you create a double wall brick structure, put the husk over this and put the polythene tube with holes and the water keeps dripping in the airspace. The airspace temperature goes down and thereby the temperature of the chamber goes down. So this a farmer can create in the field and then store the vegetables, fruits in a secured environment and so that he can sell it, keeping the shelf life increased by about 10 days, 15 days, depending on the produce. So this is a simple solution where nothing is to be done. He has to create only a double wall brick structure. Similarly, we have also produced where electricity is available. We have created a sensor which can differentially measure what is the ambient temperature outside. If it is 40, 42 degrees Celsius, inside you want 10 degrees to keep the vegetables and fruits. So this will measure the differential temperature and economically use the power to keep the chamber temperature cool, where you can keep the horticulture produce. So this is yet another important. Cool is the innovation which we have produced. Third one is for 3 fruits. India produces a large quantity which is perishable. Mangoes, papayas, bananas. These 3, India is very good in these fruits. So what we have done, MCP1 is a chemical which can reversibly block ethylene receptors. As you all know, ethylene is required for ripening of the fruits. So this will delay the ripening by blocking reversibly the ethylene receptor, thereby delaying the ripening process. And you can increase the shelf life of the produce. So you see simple solutions. So all that farmer has to do, put the 4 poles, polythene sheets over this. He has made a chamber. We have given a pump which will spray the aerosol within this chamber and then it will be uniformly distributed in the chamber MCP1, which will then combine with this, but it's safe. This chemical is very safe. So this again, you can increase the shelf life. We have seen increase by 45 days, particularly bananas, papayas, and mangoes. So these are solutions in post-harvest which India, our Amity has given. But then you should now take a look at new solutions for floriculture. And because the floriculture also comes under horticulture. So look at new solutions. Then you can also use artificial intelligence, IoT, for precision agriculture. When you are looking at the productivity, how do you optimize the use of irrigation water? By using drip irrigation operated by IoT and the sensors, which will look at the moisture sensor, which will indicate what the soil require, how much this crop require in terms of the water. So you should be able to use such technologies so that there is a precision agriculture, sustainable agriculture. That's where organic agriculture comes, biofertilizers, biopesticides. We are also working biopesticides here, biocontrol of plant disease management, both trichoderma as well as nematode-based biocontrol of plant diseases. Amity is working. And also we are working on from the potato. Luther Kaushik herself has produced a biopesticide, which is now used as a biocontrol of these diseases. So like this, biocontrol of plant diseases even in horticulture produce is a very important area. Then we wanted to double the income of the farmer. So Amity produced a very innovative technology. How do you double the income of farmer? So we created, you can see it today also in this field, we have created in a 0.25 acres, we have created a solar farm. You can cultivate horticulture produce. We have produced vegetables there, tomatoes, brinjal, so those kind of vegetables. Then we have erected the poles and we have put the photovoltaic in a slanting way, put the water sprinkler on that, because when the dust settles down, the efficiency goes down. Similarly, when the heat develops underneath during the day, efficiency goes down of the photovoltaic. So what we have done is we have put the water sprinkler operated by a solar pump. So you just switch on the solar pump, it just flushes all the dust which is settled down on the photovoltaic. This water goes and irrigates the crop, horticulture crop, and so water is also saved. And then the bottom of this heating up is taken care of by the transpiration of the plants, which acts like a heat sink to take away the heat. Thereby, the efficiency of photovoltaic goes up. So this is how we have got the income for the farmers at the periphery of this, and we have optimized the distance, what should be the interpole distance and so on. So we have put a plant of 40 of these, each one gives 300 watts. You get 12 kilowatts. 2 kilowatt the farmer can use, and for his solar pump as well as charging the mobile or fans and others. And the 10 kilowatt, he put it on the grid. So he gets one income from the solar farming, the other one horticulture farming on ground. This is what is innovation. This is how we have doubled the income. And the Prime Minister's office has taken this for propagation to all the states. Prime Minister picked up two technologies in 2 years ago. All science secretaries were made to make a presentation to PM on innovation from their ministries and departments. So they presented, PM picked up two. One of this is Amity's, the solar farming, which he keeps talking about in Man Ki Baat and all this. So thank you, Prime Minister, for recognizing this Amity's contribution in solar farm. Now coming to the message, what I want to give the carry home message, particularly for students and also my faculties, this is time for us to make sacrifice. Viksit Bharat will not happen just like this as a magic. Or, we got our India's vision about 70, 80 years ago or 100 years ago was to get freedom, independence. Independence was the first vision to our nation. The first vision India had was India should become independent, free India. And everybody sacrificed. Somebody went to jail. Some people were killed. They gave their life. They sacrificed their families. They sacrificed their comfort. This is how we got freedom. First vision was realized with that. Now, second vision, we don't need that. But we want all of us to roll up your sleeves, come out of the comfort zone, give your best, 100%. 100% of yours, if you give, Viksit Bharat will happen. So in a horticulture sector, agriculture sector, we would like all these students, faculties, all of us that we should give our 100% so that self-reliance in food as well as surplus food, we will export to other countries, earn revenue, we will contribute to our GDP. Why only 18%? It should be 25%, 30% GDP should come from agriculture sector. So think big, work on this. I'm sure Amity is always there with that idea. So I would appeal to clarion call to everyone who is attending this, both offline, online, that let's all work together, joint hands together, and then create. And it's possible. There is a Tamil Tirukural. I don't know how many of you Tamil, but I'll give the meaning. I am from Tamil Nadu. எண்ணிய எண்ணியாங்கு எய்துப எண்ணிய திண்ணியராக பெரி. It means you can achieve anything in life if you are determined to achieve and work for it. That is the message of this Tirukural. எண்ணிய எண்ணியாங்கு எய்துப எண்ணிய திண்ணியராக பெரி. You have to be strong, committed, working, contributing. You can achieve anything. You can manifest. Human potential is so immense. You can manifest anything you intently desire. This is the potential of your Atma, the power. So use that, make India Viksit Bharat. Best wishes to you.
Thank you, sir, for setting the context so beautifully. Respected dignitaries and dear participants, due to unavoidable circumstances and her busy engagement, our Honorable Vice Chancellor Madam, Dr. Balvinder Shukla Ma'am, she is unable to join us at the moment, and we hope she will be joining us later. So we now proceed with the official e-release of the ICRAHOR 2026 abstract proceedings. Yes, ma'am. I take it. Ma'am, we have to share.
स्क्रीन कर दो पूरा एंटायर स्क्रीन कर दो स्क्रीन ही कर दो ना अब बताओ कहाँ है एब्स्ट्रैक्ट बुक रिलीज उसके बाद इसको स्टार्ट प्ले हो गया
I have it in the PPT. I should add in PPT.
अभी नहीं सर मेरा की बात you can start you can read it सर आप ही आइए आप शेयर कर दीजिए
शेयर करवा लेती
शेयर कर दीजिए बेटा प्लीज शेयर कर दी ओहो ना आप इसको प्ले कर दीजिए यहाँ से जस्ट क्लिक इट जस्ट क्लिक इट the play button
over it and just like this.
So this book is available on website and we can just play the book link है इसमें book link लिंक है पीपीटी पर हाँ पीपीटी हाँ
वो नहीं
दूसरा पीपीटी I think we have given the QR code outside at the registration desk. You can scan the QR code and then access the abstract book. So it is available online. It's a flip book which you can access. So please go through the this thing. हाँ, इसको हाँ कर कंट्रोल है। Okay. Okay. नहीं होगा. I think the internet is slow. Very slow. Okay, so you can download the abstract book by scanning the QR code available at the registration desk. Thank you. We just wanted to show you, but because of the network, we are unable to show it here. Thank you.
Thank you, one and all. Now it's time to introduce our guest of honor. Oh, I'm so sorry. Now I would like to request our event sponsor, Mr. Kamal Kumar from Dhanuka, to give their kind remarks. After that, we move into like introducing our guest of honor.
Good afternoon to all of you. It's a privilege and an honor for me to address all of you, distinguished and learned researchers here from horticulture. Dr. Salvamurthy, Dr. Nutan Kaushik, our founder, President, Dr. Chauhan, whom I have a lot of respect and I have a memory of having been on the dais along with him in Amity only about 11, 12 years back. I don't remember the date. It's a great initiative. I think third in a series for horticulture. And today, when we interacted with the students who are doing research on horticulture, it was a very, very good to witness how much contribution Amity as a private university is doing in the field of research. India has a tremendous potential. From what we were around 50 million tons in 1950, immediately after our independence, I think we have gone along, we have traveled along. And in this journey, we have reached to almost about all-time high of about 351 million tons of food grain. But horticulture, fruit and vegetables have surpassed by now the cereals. And still we are growing very, very fast. What we need to now look for is how to improve and how to increase our export, which has a huge potential ahead of us. Now we are largest producer of mango, we are largest producer of banana, we are largest producer of many fruits, but not the number one exporter. A country like Ecuador for banana is number one exporter, wherein India has the highest production of banana in the world. There are many things which I have witnessed and for which many of you researchers, including the Amity horticulture research, would make effort in trying to find solutions for. Like one, which is millibug of mango in northern part of India, which is the red rot of sugarcane in many parts of India, which is BLB of paddy, of course, not in horticulture, but when we talk of Xanthomonas citrus, that is citrus canker, I think we have to do a lot of work on finding solutions, not only for organic, but even for chemical use also. Whatever best possible, I think we'll have to work very hard. Dhanuka, the organization which I represent, we have done a lot of research along with our Japanese partners. Presently, we are with Nissan Japan, working very closely for many projects. The first which I remember was with Takeda, and it was Nichimen Corporation, then Hoko Chemicals. We partnered with DuPont. We brought, in fact, DuPont to India in many parts, including the first project was for Kajanas Kajan. It was mainly in Karnataka, part of Tamil Nadu and Maharashtra, for which I think we improved the productivity of red gram for 2 quintals to 8 quintals over a period of 3 continuous work that we have carried out. Friends, our good wishes to all of you for continuing to work in the field of research. And on the end, I will just quote one Lala Hardayal Mathur. Many of you may not have heard his name also. He's a great philanthropist India has. His last was, he was professor at Harvard. And he has written a book, The Hints on Self-Culture. One of the greatest books which I have read, and I continue to read that. And the first page of that book says that knowledge is like deep well fed by perennial springs, and your mind is like bucket. You pour into it and assimilate as much as you can. So with this, I would again wish all of you a very, very successful 2 days of intervention in horticulture research and recent trends in horticulture research. Thank you.
Thank you so much, sir. Now it's time to introduce our guest of honor. It is my privilege to introduce our guest of honor, Dr. Meenakshi Singh, Chief Scientist at the Technology Management Directorate, CSIR Headquarters, New Delhi. Dr. Singh brings over 30 years of distinguished experience in research and technology management at the national level. She has successfully initiated and coordinated numerous research and development and technology development programs, also facilitated strong collaborations with inline ministries, industries, and other stakeholders. And she had played a pivotal role in the establishment of innovation complexes and incubation centers. She currently serves as member secretary of the task force on Nutra sector on behalf of the Government of India. She holds a master's and doctorate in food technology from GB Pant University, Pantnagar, and has held significant positions including scientists at CSIR CFTRI and director at FSSAI, representing India at several international forums, including USA, Europe, and Asia. Dr. Singh has published over 30 research papers and 7 book chapters, delivered invited talks at numerous national and international conferences, and also contributed actively to academic and scientific committees across leading universities, including ICR institutes. She is a fellow and active member of several professional bodies, including Association of Food Scientists and Technologists, AFSTI, the Indian Science Congress Association, Society for Preservation of Healthy Environment and Ecology and Heritage of Agra, and the Indian Dairy Association. We are truly honored to have her with us today. I now invite Dr. Meenakshi Singh, Madam, to kindly address the gathering.
Very good afternoon. Uh, respected respected founder, sir. Of course, he may be hearing us. We are missing physically in this hall, him actually. And he always, I think Dr. Nutan Kaushik just mentioned that he wants 200, he wants 100% from each event. I think unless he fix 200, we cannot achieve 100%. So I think he's always working for, to achieve his vision. And respected Dr. Selvamurthy sir, respected Dr. Mr. Kamal Kumar sir, Dr. Nutan Kaushik, and Miss Dr. Sanya. All distinguished guests and dear faculty members and students. Of course, as already said, I think a lot of details about the conference have been given by Dr. Kaushik, and we are going to have these deliberations for 2 days. Very detailed, she has explained, and Dr. Selvamurthy sir also has given a lot of details about the CSIR and Ameti collaboration, all those things, and about Ameti, what Ameti is doing actually. I think I can't explain in 5 minutes what Ameti is doing. It's a very, very huge infrastructure and huge work, huge institution network that I think we already aware of this. And whenever I visit Ameti, I think it's always, because of some attachment with Ameti, not just, for conference purpose I am coming. Just 2 days before I got this invitation, already I was aware of this, and immediately I agreed, okay, ma'am, I will come over here. So this is already like because of this attachment with the Amity institution, what work they are doing, what affections we are getting, visiting, what kind of motivation we are getting, after visiting the Amity. So because of that only we are here. And of course, knowledge is also one of the things. So, as already said, I think third edition of the this recent advances in horticulture research, and already mixed with technology, innovation, sustainability, and without innovation we cannot achieve anything. So, innovation is the backbone of anything. So that is the thing. And just when I entered here, before 12 o'clock, I was actually part of I attended few presentation by the, students. So this is also very important, part of this international conference, Madam has included. So that actually motivates, evaluators also as well as students. And that actually gave, what kind of like entrepreneurship skills to the students to, future to get some entrepreneurship skills. And very good ideas I could hear from the last presenter, like how we can use, natural, products, how we can move. That is very, and today I think we have to move towards a natural, because we have to actually, because we are aware that synthetic, how we are actually creating a lot of health issues with synthetic usage. So this is thing, already we know that food security is enough, I think, for us. Now government is also moving the nutritional security, and that's why we are moving towards the nutritional celebration. I think this week is again nutrition pakwada, again nutrition mass, this poshak mass will come in September. So nutrition, I think horticulture research should, like already horticulture research is focusing towards to produce the nutritional biofortified crops. ICR is already doing, and one of the agenda is also like towards the to produce the processable varieties of any food crops. So that is also one of the important thing, because still we say that we have to really reduce the food wastage, but food wastage we have to reduce, and simultaneously we have to move towards the food processing levels, because India is still, we are having the, such a big country, and we are first producers in the second producer in the fruits and vegetable. In milk we are the first, as already said by other speakers. So we have to still increase the processing level. And recently I was part of some of the meeting where Minister of Food Processing, he expressed that we have to, whatever hurdles are faced by the industry, ministry is able to help them, and anybody can approach them to help any challenges faced by the ministry, so that we can have the increase in the level of the food processing levels. So this is also now ministry is able to help, and they have lot of schemes to promote the food processing level. So again, the this conference agenda is to I think lots of sessions covered that. Valorization is another part, like food waste to the, again, we have to get the value added product. And again, the sustainability, uh, we have to do the and economic innovation, and horticulture can be focused towards the plant-based protein. That is also another, approach. And government is also, some institutions already working in the area of plant-based foods, plant-based proteins. So how to get the plant-based proteins? This is also one very important area. And Amity University has got already lot of collaboration with other institutions. Before entering the MOU, even they were already working with the CSR institutions. So, with the help of the collaboration, they can have still more projects in this area. Uh, so increase in product and good varieties of the crops for the productivity. Again, productivity as already is explained by the Dr. Salvamurthy sir, that productivity is a issue. So how to increase the productivity? That is also one of the thing, and we have to really take some of the good varieties so that productivity per hectare of any crop can be reduced, can be increased. So this is also one important thing. So again, we have to move towards the, like, again, we generally are the, actually in India, are the small and marginal farmers. So we have to develop some of the post-harvest aids, like maybe vegetable cutters and all those things, tractors at a small levels, because we don't have large farm holding. So that is, already we are having those things, and that is also one of the important thing. Amity can also have it in collaboration with ICR Institute, even on CSR institutes. So again, the, tomato, onion, and potato. Again, we have lot of, wastage in these crops. So again, some good varieties of the, some good processing technologies are required and already there, so that again this kind of technology can be transferred to the rural areas, and rural based centric, some processing centers, incubation center is also another opportunity which can be uh, uh, established by the Amity or in collaboration with other institutions. So with these points, I just wish all the success to the, this conference, and thank you very much for me giving this opportunity. Thank you.
Thank you, Dr. Meenakshi, for such a wonderful idea. You rightly mentioned about that horticulture is the key for the nutrition, and uh, you mentioned about the plant protein, horticulture is source of protein. So here I would like to mention, I think Dr. Gautami can mention that we are developing one product using the moringa leaves, food product. Moringa leaf is rich in protein, and using that moringa leaves. So Dr. Gautami, if you can just elaborate. In fact, I raised the question that there might be some anti-nutrient factors which might be. So what about the clinical trials, preclinical trials, and so on? So we are one of our MSc students is working on that one. So Dr. Gautami, if you can just highlight what we are doing on that one. Dr. Prabhat Kumar is with currently sitting with the minister, and he is expected to join anytime. So meanwhile, you can just.
Ma'am, one of our MSc students, she's working on a moringa leaf powder. She's making it as a herbal tea. She wants to make it as a herbal tea. Along with, she is using rose petal powder. So for that, like, bit of color and aroma purpose. So we had a doubt, like when we are having the discussion, we had a doubt it might have any anti-nutritional factor. So, but as per moringa leaves, as per the literature we have referred, there is no such. So, may I know your like thought on? There is no anti-nutritional factor, ma'am. But we have found that in the pods of, like in the seeds of drumstick pods, we have found.
it is known that nowadays I think lot of people that we have to soak our dals 12 hours before it. Why? Because you have to reduce the heat. So traditionally, how we were cooking the dals actually in open thing, and there's some that jhag used to come and that we used to remove it. So, but nowadays because of lack of time, we are doing in cooker, pressure cooking. So that's why 12 hours is must actually before you cook any dal.
Okay.
Yes, so good. It's very important. You reduce the acidification.
So there is no problem.
Yeah, because then it leach out.
Moringa, so leaves do not have.
Leaves will not. But I think it is able to.
So from the tea, they can also develop some kind. I think one of another student is working on the moringa. Nishant. Nishant. You have Nishant is not here. I think there's another student who is working on the moringa. So this we are already focusing on this. Nishant, is somebody working on the moringa leaf products? No, अच्छा leaf seed वाला कर रहे हैं आप लोग। Papaya seed, okay, okay.
We have optimized the ratio of the millet with the refined flour, and now after optimization, we are planning to incorporate different concentrations of papaya seeds, because we have targeted the papaya seed because it has very low amount of anti-nutrients, and it's also contains thiol group, which is papaya seeds. It contains thiol groups, which contains various types of properties like radioactive properties. It has ability to eliminate the radioactive property, and also provide the antimicrobial and antioxidant activity as well.
See, moringa, there is a research done by Dr. Harina. He has brought a tablet, Moringa Bullet. He has, if you see the brand Moringa Bullet, which gives anti-arthritic properties from the leaves. So there is already a product available in the market, Moringa Bullet. And so Moringa leaves are not having any anti-nutritious factor. Yes, whole, Moringa, the whole plant. Yes, even drumstick. We put it in sambar and we make sabji. It's useful, very useful. Good.
Excuse me, in moringa we have an anti-nutrient factors, that is oxalates, but it is not so much. As you know, in case of most of the leaf vegetable, oxalate is one more. But even in the list of the moringa also, there is some percentage of the oxalates, but not much.
Hello.
Thank you, sir. Sir, is there any method to like reduce its content to like nil? Is there any methods we can employ to reduce the oxalate content to nil, like 0?
You are like at the time of the drying of the leaves. So, but because in moringa, if the leaves is the fresh leaves, you will get the more oxalate. But when you dry the leaves, so there is the oxalate things will be reduced. So that's because in your case you are doing the drying leaves.
Yes, yes.
So
And further, I think boiling also reduces the oxalate content. Boiling is also because water treatment reduces this one.
In South, there is a practice when you convert butter into ghee, they add the leaves of moringa leaves and then they convert this. It gives a fragrance as well as nutritious value.
And
So conversion of butter to
somewhere I was reading that Modi ji is very fond of the moringa leaf paratha. Paratha. Just like the methi paratha, he makes a moringa leaf paratha. So that's a very good thing that we are incorporating the protein in our diet, and it's very highly nutritious. So moringa is a very wonderful tree. I think we developed one project on moringa. An integrated network on the moringa development, holistic development, and we should take it further with forward with CSIR. that network project.
Not that much
No. Yes.
So the better part is more useful sometimes.
Actually, I had discussed this project with Dr. NVRI director. I think we will be taking this further. So Monica would be our next project proposal, which we will be submitting in CSR. Dr. Prabhat Kumar is just joining. He has just given a message. He just finished the meeting and he's just joining. Just check if Dr. Prabhat Kumar has joined. Here, just check it out. IT, can you check Dr. Prabhat Kumar has joined or not? IT?
Dr. Prabhat Kumar. Dr. Prabhat Kumar.
He said he's joining, just joining. Actually, nowadays it's a very bad, it's a very hectic week for not only outside MIT but also within the MIT also. We are having presentations on MIT Boundless, which is a new concept came in MIT, where we are giving two majors and one minor offered to the students. And today is the presentation by all the institution. It's a kind of fair where students will go to different institutions and learn about the different majors and minors. And we are also supposed to be going to participating in that one, but we have taken the excuse for no. So it's a very busy, hectic week, and I'm happy that despite that, you people all are here. And okay, thank you.
So Dr. Prabhat Kumar sir has joined online. It is now my great honor to invite Dr. Prabhat Kumar, Horticulture Commissioner, Government of India, who is joining us virtually. Dr. Kumar holds a PhD in horticulture with specialization in floriculture and landscaping from IARI New Delhi, and he has made significant contributions across teaching, research, and extension. He has served in several prestigious institutions, including IARI, GB Pant University, contributing significantly to teaching, research, and capacity building in horticulture. His contributions in floriculture include the development and release of improved varieties such as Pusa Deep and Pusa Bahar in marigold and Pusa Sinduri in gladiolus, along with the standardization of cultivation practices and promotion of sustainable approaches in ornamental horticulture.
IT, Dr. Prabhat Kumar ko focus.
He has been actively involved in national and international level programs and has made significant contributions through over 50 high quality research publications, mentoring MSc and PhD students, handling 14 research projects, and conducting extension activities aimed at advancing floriculture and benefiting the farming community. With his vast experience and leadership in this field, he continues to play a pivotal role in shaping the future of horticulture in India. We are truly privileged to have him with us today, and I now invite Dr. Prabhat Kumar sir to kindly address the gathering virtually.
Thank you, sir, for joining despite your busy schedule. I really honor, and we are really honored to have you here. Can you please, sir, आपका video on है क्या? Hello, sir. Can you hear us?
Ma'am, sir didn't open the camera right now. Right now, he's not open the camera. He joined on the session.
Acha. Okay. Should we wait? Okay. उनको अनम्यूट तो करिए, वो तो म्यूटेड है. आपने म्यूट किया है क्या?
No, ma'am, he is already muted himself.
ओके ओके. हाँ. हमारे यहाँ से नहीं है. अच्छा 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 अच्छा. बस फेलिसिटेशन हो रहा है ना. इसके बाद फिर फेलिसिटेशन. वो छोड़ लो, भी तो दे रहे हैं. वेलकम जी सती जी, बस हमारे पास 5-10 मिनट हो रहे हैं, लास्ट कैच बोल रहे हैं। हाँ ठीक है ठीक है ठीक है ठीक है, 15 मिनट में मैं आपको बता दूंगी, मैं बता दूंगी। ठीक है। तो फेलिसिटेशन कराते हैं क्या? अच्छा नहीं लगता। जी सर।
Yes, yes. Hello.
Yes, sir. Thank you, sir. Thank you, sir. Thank you, sir. Invite him again. Thank you, sir, Dr. Prabhat Kumar, for joining. Thank you so much, despite being
I'm
with the
very
minister.
sorry. Actually, I was stuck in one of the meeting, and so
Thank you so much uh, for uh, for this honor. Thank you, sir. Uh, uh, you can invite him again, yeah, please.
It is now my great honor to invite Dr. Prabhat Kumar, Horticulture Commissioner, Government of India, who is joining us virtually today. Dr. Kumar holds a PhD in horticulture with specialization in floriculture and landscaping from ICRAHOR New Delhi and has made significant contributions across teaching, research, and extension. He has served in several prestigious institutions, including ICRAHOR and GB Pant University, contributing significantly to teaching, research, and capacity building in horticulture. His con- With his vast experience and leadership in the field of horticulture, he continues to play a pivotal role in shaping the future of horticulture in India. And sir, we are truly privileged to have him with us. And I now invite Dr. Prabhat Kumar sir to kindly address the gathering. Over to you, sir.
Okay, thank you very much. And at the outset, let me just put my apologies. I was actually in one of the very important meeting. I could not come at a time, but I'm very thankful to the organizers. They have given me this opportunity to be the part of this very well thought that recent advances in horticultural research that ICRHR 2026. It is a bell in time and it is very pertinent to discuss on this topic. And in the recent budget announcement, there was one announcement that is high value crops, HBC. And in HBC, if you see, total crops dealt in that particular budget announcement, all were of horticulture, like cashew and cocoa and the coconut. And nuts were there, walnut, almond, and pine nut was there. And later on, sandal and, agar was also added. So if you see the horticulture per se, it is a very important sector in the India. Why it is important, I will tell you. Because if you see the total production from the limited area, that is a 29 million hectare we are touching now, and our production is about 370 million ton that has gone. So if you see, it's a bit the minimum area, how much production is there, number one. Why this production is happening? Because traction is there. Now the food basket is diversifying. If you see, since our independence, in 50 million ton, our food grain production was there at that time. Horticulture data was not available. But in the last 8th plan, if you see from 8th plan, that budgetary allocation happened with the horticulture, and the growth is spectacular. And now I will link it with your service sector, how the economy is growing and horticultural demand is increasing. So earlier, if you see, the total agriculture was having the highest GDP. At that time, horticulture and allied sector like your meat and the poultry was not in demand, only it was a carb diet. If you drop a very good graph, you will find a very good relation how the economy has grown up and attracted these crops. So now India is poised to migrate from the carb diet to the vitamin diet, protein diet, and mineral rich diet and protein rich diet. Because from the neighbor, if you see, we have read very good article in China. When they started with the carb diet, finally they migrated to the protein diet and the vitamin and minerals diet. This horticulture is very important for nutritional security. So nutritional security, and as you know, in India, the vegan, that is one issue where vegan diet is big in demand. And in vegan diet, you have to add only horticultural crop and the other allied crops, pulses. So that way, horticulture is very important. But I will now, because it is a recent advances in horticulture you are discussing, the importance is like environmental aspect is there, carbon trading. So many things are there. At a national level, we are seeing. But now what science can play a role, because we are here for the recent advances in horticulture research. So I would urge the people, those who are there and discussing, you have to now develop. Time has come not for generic recommendation. Now time has come for the specific recommendation. And knowledge creation is not a job of the now academics only. If you see at a world level, and you see we are going for the knowledge creation, PhD is happening, MSc is happening, we are writing the books. But ultimately, whether we are baking our knowledge or not, so whether mature knowledge is coming from or not, once it is a mature knowledge, then only it can be a translated knowledge. And so knowledge has three phases. Creation of knowledge is a job of the academic. It should be continuous. But all generated knowledge cannot qualify as a commercial knowledge. That we have to see. So one thing that is very important. And second thing, the scientist has to see end to end. In horticulture, earlier what was there? Basically, we have put a lot of money, human capital, and the infra for the downstreaming, where variety, then planting material production, then giving the infrastructure for productivity. Now, I'm not saying that is a saturated, but now we have to migrate from the upper stream. That upper stream is a value addition, where valorization has to happen. And crop to crop, you have to develop a value chain. It's not like a generic value chain we should recommend. Suppose that if you are just, I will give example, it is from Noida. I'll give you the example like mango you are taking out. So in the mango, you have see from the production, if you are going, what type of diversification is happening in the Indian market and the international market. So what type of product we can make? Like, and during the adversity also, this post-harvest should become a insulator to the farmers, like a unripe mango if falling. Suppose that any casualty is happening, you have seen it's a ground level. If you are from the village, you might see when the high wind is there, lot of unripe mango you are finding. What type of suggestion you are giving? Like you see now, mango panna is available. Companies are making, but from academic point of view, where people are having the apprehension when we are going for the packed food material, are the preservatives are added or not? Can we think of some non-preservative item? Are some natural preservatives we can think of? So in one crop, how many product you can create? And that is very much important. Why it is very much important? Because it's a increasing the employability. It's a raw production is not increasing the employability. Second very important thing is that by data you can say, now if you see the India total production, 80% of the total agri produce we are just sending raw material. So it is not good. Academic institutions should look into that data and how that value addition, processed food we can give. Because I was just reading one somewhere article, up to 200% enhancement is there from the raw material to last processed product. So that we have to catch up. That is a very much important. And I will tell you one of the example. I don't know how many people are knowing clustered apple. I visited one of the tribal areas cluster in Udaipur. There it started with the pulp. Later on, that particular cluster started taking out seed, and they come to know that by science only deciphered it. It is a very good insecticide property that seed is having. Now they are selling that seed. So such type of innovation is required. Same way in the jamun, the same cluster, they thought that in one season how to survive them. The next season they thought they just picked up the jamun, and from jamun, if you go and see, it is a jamun leather is available, jamun seed powder is available, and the one that pressing it, the jamun juice is coming out. So it is a zero waste technology. Same way, I visited in the Manila and I saw the coconut, zero waste integrated park. Coconut is entering into the particular premises, immediately husk is going for some other side, then water is falling, and by evaporation, they are increasing the TSS and natural sugar. All the beverages people are there, and that is a big demand for the natural sugar. So they are adding that particular natural sugar, and when that white meat is coming out, they are making of milk, then cream, then desiccated powder as per the demand. So from one product, they are creating umbrella of that product. So such type of thought in horticulture is very important. And as you know, climate change is happening. Now I am coming to the challenges. Climate change is happening, and soil is that is a constant. So we have to find out the breed varieties which are good, suitable for the rainfed situation, where because irrigated land, food security, most of the crops are occupied there. Rice, if you see, Wheat, if you see, pulse mission is there. The other mission is an MEOS, oilseed mission, where India is importing 56% of our need. So means that security part is there. Then this nutritional security part is there. So there is a competition amongst the crops. So comparative advantage we have to find out. And for the comparative advantage, can we migrate our crop to the challenged land area, where because our plant is a perennial in the nature, particularly fruit crops, where rhizosphere can be managed, irrigation, water harvesting can happen, water budgeting we can do in that particular area with the minimal and survival irrigation by drip and micro and sensor technologies can be converted into that. And I'm happy to tell you that the Rajasthan has come up. If you go and see the Jalore area, particularly for pomegranate, earlier there was no pomegranate. Kutch area has become now a capital of the food production. So such type of models are available, and science, as you know, it is evolving. So when we are having such type of discussion where different minds are coming from the different parts, it is always good to have a discussion, but genuinely you ask the question and reason there. And I'm seeing students are there, faculty is there, and so a new student should see what type of opportunity they are having in the horticulture. Can they talk about the startup? Can they talk about, you are in the Noida itself. Many people, time is limited. I'll not give you the lot of example. Otherwise, good success stories are there. You can have a role models so that at least our students should see, and they should not restrict to only knowledge creation rather than utilization of that knowledge. So not to be hired, but they should become an employer. So now at the end, a lot of things are there. You see in the vegetable, in the spices, in now therapeutic functional foods are in demand. So n number of advantages are there of the horticultural crops, and that advantages we have to find out. And particularly, you see spices. If you are here in the research advances, one thing I will speak about the spices also. Recently, if you see your 2-3 consignments were rejected, and there was a residue problem. So can we think of that? How to go for safe spices production? Because in spices, again you have to eat without it's a raw eating, sort of raw eating is there. So a residue problem is there. Particularly, we are now trying to develop pathogens. So biological control is becoming very popular apart from the variety development. So like a variety development is a long-term solution, mid-term solution, and immediately early solution. So as a scientist, you have to think on always on 3 points. These are the challenges are there. What are the immediate solution? What are the mid-term solution? What are the long-term solution? So such type of strategies should come. And I'm again very thankful to Nutanji and patience. Actually, I'm very sorry once again. Just pressing my apologies to you people because I was stuck in some of the important meeting, and that was also for the horticulture only for the development. So we are finalizing the 6th, financial cycle. So in that we were there, and we are trying to integrate as much as science and technology, because nowadays SNT-driven only agriculture can survive. Recently, you have read in the paper El Nino that is already highlighted. What will be the impact that will we see after 15th April, and it will be clear in the May. So it means the climatic aberrations are having, soil health is deteriorating. So these are the important item, and you have to make the ecosystem. And accordingly, I think this discussion and the recommendations will be helpful for the policy making, like us, those who are at a policy level. If that is coming out, we can put in something somewhere in the policy, and it will give a roadmap for the research to the young generation too. Thank you once again for inviting me, and I wish a great success to this particular summit, what you have proposed. So I hope that the deliverable will be a very fruitful, and I request again, always prepare a bulleted point in the last that recommendation has come up, so that people can utilize in the academia, in the industry, and at a policy level too. Thank you once again.
Thank you so much, sir. Thank you. Sir, we will definitely provide you the bullet points as designed by you. Uh, I'm very happy to announce that Honorable Founder Sir is just joining. He just finished his another meeting, which was very important meeting, and he's just joining. I just talked to Satiji and he confirmed that he's joining. So Prabhat Kumarji, I would request if you can just remain online for a few more minutes. The sir,
Okay.
Honorable
No,
Founder.
no,
I would also request the suggestion which has you have been provided during your talk. If you can just give us in the writing also, so that we can incorporate in our this thing recommendations which will come from this conference. So that will be, and we will then compile all the recommendations which are coming from the different sessions, and then can circulate, give it to you for the further consideration, sir.
okay.
Thank you,
I
sir.
think recording is there, Nutanji. So you can take it from recording. I think recording is going on.
Yes, sir.
So
Okay. Thank you, sir.
recording is going on. Otherwise, I will give you the bulleted point also.
The points are recorded, and in case you have something which you have missed out, you can add on.
Yes, yes.
Okay. Thank you, sir. Thank you so much. So I will.
Patmanji, please visit us in person also at Dr. Selvamoorthy. We take this opportunity to invite you in person to come and see what all good work committee is doing. And we'll be very, very grateful if you can spare. I know how busy you are, but I would request you to kindly spare some of your valuable faculties will be immensely beneficial.
Actually, I proposed to come physically, but it was so much pressing, so I could not come. But definitely, I would love to come. And I'll inform in advance, and I'll come and visit and see, because learning is always is a continuous process. I'll come and see what type of activities are going on, and I hope that the lovely MT is doing a good job. And I visited, sir, if you remember. I think it is 1 year back I visited, physically came there. So
Thank you.
And
thank you.
thank you, and I acknowledge Dr. Patavade. Some of our international speakers are also online. Dr. Patavade is there. Dr. Nasir is there. Dr. Jagesh Tiwari is here. Dr. Maria is there, and who has joined online. So may I request each one of you, if you can just put your cameras on, and then if you want to say a few words, till we are waiting for Honorable Founder, sir, that will be great. Dr. Nasir or Dr. Maria or Dr. Patavade. Thank you for joining. Ah, hello. Thank you. We are just waiting for the Honorable Founder President. Dr. Nasir is here. Welcome to Dr. Nasir. We have been, he's one of our great collaborators. We have been collaborating for last more than 8 years now, working on endophytic biocontrol, endophytes as a biocontrol agent for the vegetable crops. And recently we have been given, got another project on, I think on the wheat, biopriming of the wheat seeds. So over to you, Dr. Nasir, you can give your few remarks. Not the presentation, but just the remarks.
Hello?
Just the remarks for a few seconds. We'll be waiting for the Honorable Founder, sir.
Okay. Do you hear me?
Yes, we can hear you, but this is not your presentation time, but we are just asking the remarks from you.
Okay. So it's not now?
Yes.
Okay.
But
Thank you.
the presentation will be later in the session. So we are still with the inaugural session now. So I'm asking for some remarks from you since you have been associated for all the 3 conferences with us.
Okay. Thank you.
Thank you. Would you like to say some words? तीन चार मिनट ओके 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 we can do the felicitation till that.
Now, we take this opportunity to felicitate our esteemed guest of honor, Dr. Meenakshi Singh ma'am. I request respected Dr. W. Selvamurthy sir to kindly come forward and do the honors. Now, we also take this opportunity to felicitate our sponsor, Mr. Kamal Kumar, for his valuable inputs throughout. I request Dr. Nutan Kaushik madam and Dr. Doyley madam to kindly come forward and do the honors.
Honorable founder sir अभी join कर रहे हैं. He's like finishing the other commitment meeting, which is a very important meeting in Lucknow, where the deputy CM has joined for the program. So he's just finishing and he has given a message that he's joining in 2-3 minutes. So till that time, I would like to highlight about our honorable founder president, like what he is, and yes, he has joined, sir. Good afternoon, sir. Namaskar, sir. Thank you so much, sir. For huge round of applause.
You just left Lucknow, Amity University, Lucknow, and for him, research and innovation, particularly in horticulture, agriculture, is very important. So thank you, Founder President, for joining us. I'm grateful to you.
Thank
and we
you,
all
sir.
seek your blessing because he attends several functions at the same time. This is all this parallelly. So it's our fortune that today we have our founder president addressing us, and he doesn't need any introduction. But just I want to mention that his only vision is how do we make our India a Viksit Bharat, Atmanirbhar Bharat, and also make our country a knowledge superpower. So this is what is his vision, and let us hear founder president, and we seek your blessings, founder president. Over to you.
थैंक यू सर. मैं बड़ी कृतज्ञ हूँ आपकी कि आप हमारे सारे प्रोग्राम में आकर के हमको ब्लेसिंग देते हैं सर. थैंक यू सो मच सर. थैंक यू सर.
We are also having Prabhat Kumar from the
horticulture. नूतन जी, एक लोग कहते हैं, कौन कहता है जब नूतन जी बुलाए तो चौहान जाते नहीं. तो अभी मैं वहां पे डिप्टी चीफ मिनिस्टर गए हैं, तो तब तक मुझे उनका बैठना जरूरी था. तो जैसे ही गए तो एकदम भाग के मैं आ गया. दूसरा बात, लोग कहते हैं पहले स्लेव्स हुआ करते थे. सेठवामूर्ति जी, अब तो हमारे यहाँ स्लेव्स है नहीं. मैंने कहा हूँ ना मैं, जो उधर शिवानी ने बुलाया या इन्होंने बुलाया, तो मैं तो भाग दौड़ ऐसे करता ही रहता हूँ. पर आज बहुत मुझे उत्साह मिल रहा है, बहुत प्रेरणा मिल रही है कि हमारे प्रभात कुमार जी आए और हमारे
नमस्ते सर जी।
कमल कुमार जी आई, और ऑल्सो मीनाक्षी जी, दो बहुत ही CSR की एक बहुत ही टॉप लेडी है। और मैंने उन्हें कहा जब बाहर रिटायर होंगी तो मैं ही लेके आऊंगा उनको अपने यहाँ। शी इज सो कैपेबल। जब हम जाते हैं वहाँ, एक दिन MOU करवाने गए थे तो थोड़ी देर हो रही थी, तो उन्होंने हम वहाँ के डायरेक्टर जनरल को रोक के रखा। तो आई नो दी पीपल। सो जो भी इसमें आए हैं मैं पूरा देख नहीं पाया, पर मैंने इसको नूतन जी यूट्यूब पर डलवा दिया था। तो बहुत से मेरे एल्यूमिनाई के व्हाट्सएप आ रहे हैं पूरे वर्ल्ड से कि बहुत अच्छा प्रोग्राम है, हम पूरा देखेंगे। क्योंकि ये ऐसे प्रोग्राम है जैसे कि अभी वहाँ भी बोला गया कि हमारा देश कृषि प्रधान देश है। तो ये जो टॉपिक है आपका बहुत ही एप्ट टॉपिक है, क्योंकि हमें इंडिया में कृषि में तो हमें नंबर 1 बनना ही है, परंतु भारत को हमने बहुत जल्दी 3rd रैंक पे लाना है। और फिर मैं कहने का हिम्मत करता हूँ, लोग बुरा मानेंगे, कि धीरे धीरे 1st रैंक पे भी लाएंगे। जो हमारे 140 करोड़ में स्पर्धा है, जो जो इनोवेशन की पावर है, जो इनमें शक्ति है। तो मैं तो 28 साल जर्मनी रहा हूँ, वहाँ बहुत बड़े R&D का हेड था। सारे 20-50 लोगों के लोग मेरे मुताबिक थे। तो मैं अपने स्टूडेंट को ये कहना चाहूँगा, जो साइंटिस्ट है, कि हमारे इंडिया की विजडम का, इंडिया के संकल्प का, इंडिया के एफर्ट्स का कोई मुकाबला नहीं है। मेरे कहने का महत्व है, क्योंकि मैं जब ईस्ट और वेस्ट का यूनिफिकेशन हुआ तो मैंने अपने लोगों को बुलाया हिंदुस्तानी स्टाइल से कि आधे घंटे में आ जाओ। तो उन्होंने कहा पता नहीं क्या हो गया, फाउंडर में बुला रहे हैं, चेयरमैन बुला रहे हैं, आ गए। मैंने कहा कि मुझे ईस्ट वेस्ट के जो यूनिफिकेशन में नंबर 1 इन्वेस्टर बनना है, टेक ओवर किंग बनना है। तो अब इंडिया में रूल होता है, बॉस के सामने ना भी समझो तो हंस नहीं सकते। तो सब लोग तो सुन तो लिया, but I am telling to my students and to my guests, please help us and guide us. We will show that India becomes the world power in science, technology, and innovation. अभी सलमा मूर्ति ने मुझे बताया वहाँ लिख के कितने पेटेंट करे हैं। मैंने कहा मोदी लिख दो, मैं वहाँ बताऊंगा कितने पब्लिकेशन हुए हैं। 8 लाख एल्यूमिनाई मेरे पूरे वर्ल्ड में है, 2.5 लाख स्टूडेंट पढ़ रहे हैं। तो ये मैं इसलिए कह रहा हूँ कि जो भी यहाँ पे हमारे यहाँ गेस्ट पधारे हैं, जिन्होंने टाइम दिया है, आप हमें गाइड करिए, हमें मोटिवेट करिए, और हम लोग करके दिखाएंगे कि आपका आना यहाँ पे, आपका भाषण, आपके विचार कितने महत्वपूर्ण थे हमारे लिए। और नूतन जी का तो मुकाबला ही नहीं है। तो इनका तो ये जब दूसरे का उसमें थी वहाँ पे, तो जब आई तो मुझे विश्वास नहीं हुआ कि मेरे पास छोड़ के आ जाएगी। तो 6 महीने तो मैंने को तवज्जो नहीं दी। और ये इस वक्त पूरे वर्ल्ड में इनका नाम है, जो भी प्रोग्राम करती हैं किसानों के लिए, बहुत स्पेशल प्रोग्राम करते हैं। तो नूतन जी का तो मैं कितनी तारीफ करूं, जो आप लोग सब आए, इनके कहने पर आए। तो अभी मैं इसको बाद में पूरा नूतन जी देखूंगा पूरा प्रोग्राम आपके यूट्यूब पे। कोई भी देखना चाहे तो डाल दीजिए MIT यूट्यूब, और प्रोग्राम का नाम डाल दीजिए तो सारा प्रोग्राम आ जाएगा। मैं इसलिए डाल देता हूँ कि ये प्रोग्राम हमारे पूरे वर्ल्ड में जो एल्यूमिनाई हैं, कॉन्ट्रैक्ट पार्टनर हैं, यूनिवर्सिटीज हैं, उन सबको मालूम होना चाहिए कि MIT का विचार क्या है, MIT का एक एम क्या है, जिससे कि सबका सहयोग मिल सके। डॉक्टर शिवमूर्ति जी, आपने जो दिए थे वो नंबर मैंने सब पढ़ के सुना दिए हमारे उप मुख्यमंत्री के लिए। बड़े खुश हो रहे थे कि देखिए इतना काम हो रहा है MIT के यहाँ। तो मैं बहुत कुछ धन्यवाद देता हूँ सबको, और मेरा आशीर्वाद तो माय स्टूडेंट्स माय रिसर्च स्कॉलर्स, आपके लिए तो क्या कहूँ, मुकाबला नहीं है। पर एक ही लक्ष्य रखो कि हमें भारत को 2047 में विकसित भारत तो बनाना ही है, परंतु एक नंबर 1 इन साइंस एंड टेक्नोलॉजी बनाना है, और हमें एक नंबर 1 कंट्री बनाना है। उसमें कोई रोक नहीं सकता, क्योंकि 140 करोड़ में large percentages of youth, of people. So my 2.5 lakh students, 8 lakh alumni are showing day by day. Even school students are working in the area like space science, agriculture, और यमिता चौहान जी जो है उसके चेयरमैन है। तो मुझे देखकर लगता है कि जो भी हमारे पास आया, टाइम दिया, तो बहुत महत्वपूर्ण है हमारे लिए। बस यही रिक्वेस्ट है कि आप हमें गाइड करिए, आप हमें विचार दीजिए अपने, और उसको कार्यान्वित करने में हम सब लोग लगे रहेंगे, और देश को एक टाइम आने पर सुपर पावर बनाना है। सबको बहुत बहुत धन्यवाद। नूतन जी, बहुत बहुत मेरा आशीर्वाद, शुभकामनाएं। डॉक्टर सिल्वा मूर्ति जी, आपके अभी दो बड़े भारी इंटरव्यू देखे मैंने, स्पेस साइंस में तो आपका मुकाबला नहीं कोई भी। तो मैं सबको दिखाऊंगा, तो ये आपको भेजूंगा, इन्होंने स्पेस साइंस में डिलीवर करे जो नया जो एक सिस्टम डेवलप हुआ है फॉर द एग्रीकल्चर एंड स्पेस साइंस। तो बहुत बहुत धन्यवाद सबको, प्रधान जी को, मीनाक्षी को, और हमारे टीम और गेस्ट को जो भी आए हैं, मेरा बहुत बहुत आशीर्वाद, शुभकामनाएं।
Thank you, Founder President. Founder President just mentioned one important agriculture in space. Amity is the first one to initiate this. This is what he mentioned last remark, that we have put a calyx of a spinach in space. In the poem 4, this payload from Amity University, Maharashtra has gone. So I want to tell you that Amity is looking at how do we make agriculture in space. When we go to International Space Station, when we create habitation, you need food. So Amity is the first one to send the biological payload from India to space in India. It is Amity University. This is what Founder just now mentioned. So we not only do agriculture in the land here, we are also doing it in space. We have started thinking about it. Thank you, Founder President, for bringing such great initiative in Amity Education Group. And we are so grateful, and we will implement all this, your dream, because he has a philosophy, success by compulsion. You have to succeed. Once you want to say that this will be achieved, Viksit Bharat will be achieved. We are all there with you, Founder President, and your mission to make this country a superpower.
Very good.
Thank you very much, sir. It was a very nice deliberation by you in within no time. और आपने जो बात बताई, एक्चुअली क्या है कि विकसित भारत में फिजिकल के साथ साथ जो इनटेंजिबल है, ह्यूमन कैपिटल एंड नॉलेज इकोनॉमी, तो चौहान साहब का जो नॉलेज इकोनॉमी में काम चल रहा है, आई थिंक इफ वी वांट टू सी 2047 एज ए डेवलप्ड इंडिया, so how much share we are having in our knowledge economy, that is more important. एंड जैसा कि जियोपॉलिटिकल सिचुएशन को देखते हुए सेल्फ रिलायंट फूड की अगर हम बात करते हैं, तो आई एम वेरी थैंकफुल एंड कंग्रेचुलेशन टू यू सर, यू हैव स्टार्टेड एग्रीकल्चर वेरी अर्ली एंड यू थॉट ऑफ एग्रीकल्चर। और एक सेइंग है, आप तो रहे हैं जर्मनी में, उधर कहा जाता है कि इफ एग्रीकल्चर स्नीजेस अदर इकोनॉमी एक्चुअली गॉट कफ। तो जहां अगर यहाँ ठीक आ गई तो वहां पे कफ शुरू हो जाता है। तो हाँ, एंड द फूड इज वेरी इंपॉर्टेंट एंड सेफ फूड इज वेरी इंपॉर्टेंट। और आपने जैसा कहा कृषि प्रधान, अभी हम लोग चेंज कर रहे हैं, अब इसको वाणिज्य पे ले आ रहे हैं, क्योंकि वो हमारे गीता में कहा गया था कि भारत की महत्ता वाणिज्य में है। तो कृषि प्रधान में हम लोग अभी बात कर रहे थे कि हाउ टू गो फॉर अप स्ट्रीमिंग एंड डू द पोस्ट हार्वेस्ट चेन डेवलपमेंट, एंड दैट कैन कम फ्रॉम MIT very well, because a lot of you have a computer science, you have other engineering. So now it's marrying the science, not doing isolation. That is very much important, and that campus can give. So thank you very much for coming and blessings the people and the students and us also. Thank you very much.
दक्षिणामूर्ति जी, ये जो हमारा स्पेस साइंस का एक 7 मिनट का वीडियो है, दक्षिणामूर्ति जी, हेलो, दक्षिणामूर्ति जी, वो जो हमारा 7 मिनट का वीडियो है स्पेस साइंस वगैरह का, तो प्रभात कुमार जी को, मीनाक्षी जी को और कमल कुमार जी को भिजवा देना, so they know that which area we need their guidance and advice. And I think Nutan ji, I'll come again in your program. I think 2 days program hai, so I will have more time to speak to my people there. But I'm very grateful to Prabhat Kumar ji, Meenakshi ji, Kamal Kumar ji for coming. I'm so grateful. Thank you.
Thank you, sir. Thank you.
A big applause once again to Founder President.
Give him a standing ovation, please. Thank you.
मैं देता हूँ सबको स्टैंडिंग ओवेशन, मैं सबको देता हूँ, जो मेरे गेस्ट आए हैं, जो मेरे स्टूडेंट हैं। थैंक यू वेरी मच, थैंक यू।
हमारे लिए और आपकी ब्लेसिंग की वजह से हम, थैंक यू सर।
Now I invite Dr. Doily Sanil Madam, Director, Amity Institute of Organic Agriculture and co-convener of today's ICRAHOR 2026, to deliver the vote of thanks. Over to you, ma'am.
Thanks, Gautami. A very good afternoon to all of you. On behalf of Amity Institute of Horticultural Studies and Research, Amity Food and Agriculture Foundation,
and Amity Institute of Organic Agriculture, I take this opportunity to extend a heartfelt vote of thanks following the inaugural session of the Third International Conference on Recent Advances in Horticulture Research, ICRAHOR 2026. I would like to begin by expressing our gratitude to our respected founder president, Dr. Ashok Chauhan sir, for his visionary leadership and continuous inspiration. I extend my heartfelt thanks to our Honorable Chancellor, Dr. Atul Chauhan sir, for his dynamic vision and continuous efforts in promoting global exposure, industry integration, and excellence in higher education. I also express my sincere thanks to our respected Vice Chancellor, Dr. Balwinder Shukla ma'am, for her encouragement, motivation, and constant support in nurturing a progressive and student-centric academic environment. I express my sincere gratitude to Dr. Selvamurthy sir, President ASTIV and DG ADSI, for his insightful introductory remarks and continuous guidance. We are deeply grateful to our guest of honor, Dr. Meenakshi Singh, Chief Scientist at Technology Management Directorate, CSIR, and Chief Guest, Dr. Prabhat Kumar, Horticulture Commissioner, Government of India, for gracing this inaugural session and sharing their valuable insights, which have set an inspiring tone for the conference. I would also like to acknowledge the release of the ICRAHOR 2026 abstract proceedings, which marks an important academic milestone of this conference. My heartfelt thanks to all the participants, researchers, academicians, students for being a part of this inaugural session. I would like to extend special thanks to our sponsorship partners, Dhanuka Agritech Limited, Shri Kamal Kumarji is right here, RAR Life Sciences, and also our media partner, Agriculture Today, and publication partner, BioWeb of Conference, for their valuable support. A special word of thanks to the organizing committee, convener, coordinators, faculty members, student volunteers for their dedicated efforts in successfully organizing this inaugural session. We acknowledge the contribution of our IT team for ensuring smooth technical operations and seamless hybrid connectivity. With this, we conclude the inaugural session and now look forward to the upcoming technical sessions. Thank you.
I now request everyone to kindly proceed for lunch at F2 foyer. Our poster presentations for session 1 and 2 are running simultaneously, and we will reconvene at 2:30 p.m. So kindly join us on time. Thank you, one and all.
How many speakers?
Anamita ma'am,
Just for
Good afternoon once again, everyone. I hope you all had a, I hope you all had a refreshing lunch break. We now resume the sessions. We now begin session one on breeding and biotechnological innovations in horticulture. This session will be highlighting on recent advances in molecular breeding, genetic improvement, and biotechnological interventions aimed at addressing current challenges in horticulture sector. To carry forward the session, I now invite session coordinators Dr. Anamika Verma and Dr. Pragya Barua to kindly take over the session proceedings. I would also like to invite our rapporteurs Dr. Deepshika Thakur and Dr. Kshitij Parmar, who will be documenting the proceedings of this session.
Thank you, Dr. Gautami. Myself, Dr. Anamika Verma, I'm Assistant Professor in AHSR, Amity. It's my privilege to introduce Session 1, the chairperson of Session 1, Breeding and Biotechnological Innovation in Horticulture, Dr. Shailendra Kumar Dubey, sir. He is currently serving as Professor Management at Indian Institute of Packaging, Delhi, and he is in charge of Incubation Center, that is Packnovation Center. Indian Institute of Packaging, Delhi. It is an autonomous body under Ministry of Commerce and Industry, Government of India. Prior to this, Professor Dubey had served popular institutes and think tanks like Institute of Management Studies, Ghaziabad, ITS School of Management, Ghaziabad, Indian Council of World Affairs, Sapru House, Institute of Defense Studies and Analysis, New Delhi, the Indian Society of International Law, New Delhi, and many more. He was also an expert member of the Syllabus Review Committee of BS, MS, and BMS programs at Indian Institute of Packaging, Delhi. His area of interest includes geopolitical and international business, WTO, business negotiations, production and operations, logistics and supply chain, management of technology, technology transfer and denial regimes, foreign policy, diplomacy, and international relations. Dr. Dubey is a mechanical engineer and did his MA, MPhil, PhD degrees from School of International Studies, Jawaharlal Nehru University, New Delhi. In his early career, Dr. Dubey qualified for Indian Air Force, Indian Navy, and worked as a researcher for non-conventional energy projects at Almora-based DRDO. Dr. Dubey was also recommended by International Selection Committee of Regional Center for Strategic Studies, Colombo, to attend winter workshop at Fudan University, Shanghai, China. He was also nominated by Jawaharlal Nehru University, New Delhi to United Nations, based Geneva, Switzerland, for his research work. Sir, I invite you to kindly provide your valuable remarks and proceed this session. Thank you. I also invite Dr. Individ Prasad, sir, to please come on the dais.
Hello. First of all, very good afternoon, one and all in this August gathering. I am Dr. Dubey. I welcome, first of all, I congratulate our dear madam here, Dr. Kaushik madam, for giving me the honest task of this chairing the session. At the same time, I also welcome my co-chair session, Dr. Deval Prashadji, and all the distinguished experts here, researchers, presenters here, those who are going to make a presentation offline and online. I wish to add here because Amity has given today's session, morning session was so interesting. First time I came to know that Amity has taken this country to the space, agreed to space sampling. So I wish to congratulate Amity for this visionary founders for this institute, university, so that we are finding so much of the good researches and good things here. I wish one more thing that visionary founder, visionary leaders like Dr. Abdul Kalam, when I was studying his book during my research days, Revolution of Biotechnology, then I never thought that I'll be witnessing the day today in 2026. I'm talking about 1990s. And I tell you, they are the truly great leaders. Because what we're talking today, it's a revolution in biotechnology, agriculture, horticulture, and this is the session which we are going to witness with the learned speakers online and offline, the kind of development happening. We have seen always this country as a begging ball. Sorry to say this, but this is a fact. India built a begging ball after achieving independence. But thanks to this country, the scientists, those who made this country self-sufficient in food grains, we are brimming with more than 350 million tons of food. What I wish to tell you all, you have impacted the policy of America. Why? Because we are no more looking. At the same time, there are challenges also. The day before, I was talking to one exporters from Africa, but they were talking about, sir, how we have got a garlic paste with us and how we are going to export. So today at this station, I wish to draw your attention, dear participants, that lots of challenges, lots of opportunities are lying ahead. And in this case, we should see how we can, because we have a vision of 2047. So we must look forward, how we can, because ultimately food security is one, food researches are one. So today's presentation, we will certainly looking forward to those researches, which certainly I wish that will be eye-opener, and all of us will be going to be enlightened with those presentations. With these words, without mincing words, I'll call upon Mr. Khatija Mika. Yes. Sorry. I'll invite our keynote address by Professor in the Biology, West Virginia State. This is Dr. Necker Zibadali.
Yes.
Is it the Professor Center de Biotechnology, Tunisia, and he is online. So let's welcome him and let's listen to his keynote address. Thank you.
Dr. Nasir Jabali, sir, he is Professor Center de Biotechnology, Technopole, Bord Cedria, Tunisia. Professor Jabali stands at the intersection of microbiology research, international scientific policy, based at the Center of Biotechnology of Bord Cedria. He leads the biological control group, focusing on the development of sustainable bioactive solutions. Since earning his dual PhD in 2008, he has published extensively and pioneered institutional advancements, including the establishment of the CBBC Project Management Office and coordination of laboratory accreditation. Professor Jabali's career is defined by cross-border collaboration, managing major initiatives across Africa, America, Europe, and Asia continents. His expertise in plant protection was recently utilized by Food and Agriculture Organization for the European-funded ASCO project, a dedicated advocate for genetic resource and African scientific sovereignty. He serves as General Secretary of the Tunisian Association of Genetic Resources and is a founding member of the Pan-African Scientific Research Council. In recognition of his global contributions, he holds an honorary professorship from Amity University, India. Sir, we welcome you. Please, you can start your talk.
Thank you. Thank you. Do you hear me? Okay. Thank you. I would like first to thank my colleague, and friend Professor Nutan Koshik for this wonderful invitation to be with you today in this international conference. So today I would like to, in fact, to talk about the phenotypic and genomic characterization of strain of Fusarium brachygyposum, which has plant growth promoting activities. So this research was done in the framework of the project of the Laboratory of Bioactive Substances in the Center of Biotechnology of Borsedria in Tunisia. So as you know that agriculture is facing many pressures. Beside the population increase, which will pressure the demand of agricultural foods. So we have the climatic change, which impacts also our agriculture systems, mainly with the increase of heats and the drought threats in many countries in worldwide. So also the pressure of the consumers, which are worried about the safety of food products. So they demand no OGM, no less use of pesticides and chemical fertilizers. So this push towards agriculture, toward sustainable systems of productions. And there is many ways to push towards this sustainable agriculture, but the main use in novel agriculture systems is the use of beneficial microorganisms. So these organisms can inhabit externally the plants and as well as inside cells. And they have, as you see here, many beneficial to the plants. They can supply nutrients. They can inhibit disease and pests, and also they can, in fact, increase resistance to many biotic and abiotic stressors. And as you see here, many of them, they inhabit indefinitely the plants. So from which we can have bacteria as well as fungi. So in fact, in Tunisia, we and especially in our laboratory, we are working on these two types of microorganisms, bacteria and fungi, and we selected many strains that they have PGP activities on several plants. But today I will talk about fungal PGP strains. So we conducted several surveys in the oases in the southern regions of Tunisia, as mentioned here. So these surveys were conducted on alfalfa, which is grown under palm trees. And we succeeded to isolate several strains, 79 endophytic fungal strains from aerial parts of these plants, and we screened them for their PGP activities, and we succeeded to select a few of them. And today I will talk about one strain which showed the most PGP activity on several crops, as you see here, on watermelon, tomato, radish, barley, beans, alfalfa, and will relatives Medicago truncatula, and as well as on palm date trees. So these strains showed beneficial effect when inoculated with about 50 grams per inoculum per 1 kilogram of substrates. So the aim of this study is to sequence, in fact, the genome of this beneficial strain and to demonstrate the functional annotation of these of their genes. In fact, to uncover the genetic basis of its endophytic style and to identify genes with potential ecological and biotechnological significance. So we extracted the DNA from this strain and we sequenced the full genome of this strain using Illumina high-sec sequencing technology. So we succeed, in fact, in sequencing the whole genome of this strain, and we assembled it, and the whole genome was published in NCBI Gene Bank database, and which is estimated about 35.76 megabase, and with about more than 12,000 gene model were predicted. So the karyotic orthologous group classification indicate a marked enrichment with general functions prediction genes, carbohydrate transporter and metabolism genes, as well as wall and membrane envelope biosynthesis genes, and with highlighting their potential role in cellular metabolism and structural organizations. So these classifications was also we did phylogenetic analysis and molecular identification of the fungi, and we showed that this fungal strain belonged to Fusarium brachygyposum species belonging to Fusarium scambinum species complex. So and the annotations of the genome of this strain showed that more than 700 genes were annotated as carbohydrate active enzymes of Fusarium brachygyposum, of which more than 300 enzymes including were assigned to UC numbers, including more than 40 cellulose binding, 62 hemicellulose binding, and chitin, cotosan, and glucan, and 8 linen pectin degrading enzymes. So on the basis of this CASIM family, we succeeded, in fact, in comparing our strain to others fungal pathogen strains belonging to the Fusarium genus, and we succeed, in fact, to show that our strains did not, in fact, cluster with those pathogenic strains. So it is not a pathogen strain, it's a Fusarium brachygyposum, but non-pathogens to plants. And we succeed also to characterize some of distinctive CASIM enzymes, which differ from the pathogens ones. And also using pathogen host interactions database, we succeed, in fact, to show that our strain have 55 loss of pathogenicity genes and more than 500 reduced virulence genes, which also show that our strains lack many virus genes in comparison to other pathogens genes, showing that it's not pathogen but PGP fungal strains. So in conclusion, this is the first report that showing Fusarium brachiojubosom whole genome, which have non-pathogenic traits, but PGP growth promoting traits. These resources provide a key reference for comparative genomics aimed at unraveling the genetic basis of pathogenic versus beneficial lifestyles within the Fusarium brachiojubosom species complex. So I would like to thank my team. Special thanks to Amani bin Alaya, which is the PhD students, and I will thank also the Get Genome project, especially Professor Sufyan Kamoun, which allow us, in fact, to sequence the full genome of our strains. And I would like also to thank my collaborators from Amity University, and I hope that we continue our collaborations in the framework of our submitted projects between Amity and the CBBC. And thank you for your attention.
Thank you, Dr. Durrani, for your comprehensive technical research work. It's so enlightening, though it's quite technical. But I hope all the participants, they might have undergone, they got this input from your presentation. And thanks for joining us from all the way from Tunisia. We welcome you. Thanks a lot for your sharing the thought process. Thank you very much, sir. If anybody is interested, please, you can raise the question also from the expert. If anybody wants to raise the question, the floor is open. Otherwise, we'll proceed. Okay, thank you. Now we invite Dr. Jagdish Kumar Tiwari, Principal Scientist, Horticulture Vegetable Science, ICR, Indian Institute of Vegetable Research, Varanasi. Dr. Tiwari is online, so we welcome Tiwari sir for his presentation. Please.
Dr. Jagesh Kumar Tiwari sir, he is Principal Scientist at IIVR, Varanasi, and before that he has worked at ICR, Central Potato Research Institute, Shimla, on potato biotechnology, including pre-breeding, tissue culture, somatic hybridization, allele mining, mapping, molecular markers, functional genomics, and varietal development. He has also contributed to various projects. He has contributed in development of 5 potato varieties like Kupri Neelkant, Kupri Jamunia, Kupri Ruby, Kupri Lohit, Kupri Uday, and 3 tomato hybrids like Kashi Shresht, Kashi Daksh, and Kashi Arya, and 2 cherry tomato varieties also like Kashi Cherry Tomato 3 and Kashi Cherry Tomato 14. He has also registered 21 genetic stocks of potato and tomato with ICR and NBPGR New Delhi for unique traits and granted with the patent also. He has also been awarded ICR Lal Bahadur Shastri Outstanding Young Scientist Award, ICR Hariom Ashram Trust Award, and National Academy of Agriculture Science Fellow, Indian Academy of Horticulture Science Fellow, Indian Society of Vegetable Science Fellow, Confederation of Horticulture Association of India, Associate Fellow, National Academy of Biological Sciences, membership, the National Academy of Science, India, and Bihar Agriculture Science Academy. His talk title is Breeding and Biotechnological Innovation in Solanaceous Vegetables. Sir, we welcome you. You can kindly proceed.
Am I audible, madam?
Yes, sir, you are audible.
Very good afternoon, madam. Thank you very much for this introduction. I'm sharing my slides. Is it visible, madam?
Visible.
Is it visible? Okay, thank you. So I'm going to speak on within a 10 minutes of time has been given to this breeding and biotechnological innovations in Solanaceous vegetable crops. I'm working at Indian Institute of Vegetable Research, IIVR Varanasi, for the last 4 years, and before that I was working at CPRA Shimla for the more than 14 years of research. Since 2008, I'm in the service and working on earlier potato, now on tomato genomics and breeding. So currently, if we see this vegetable statics, it's our target of whole vegetable crops is nearly more than 450 million tons by 2047. So looking into the target of these vegetable crops and currently contribution in total horticulture crops. So vegetable plays a very immense role in nutritional and food security. So currently this recommendation of vegetable per capita is nearly 450 grams. So in that solanaceous vegetable crops like potato, tomato, brinjal and chili, 4 crops in brief I'm going to cover. So what the current status, if you'll see in the post-harvest technology also, these post-harvest losses are very, it's quite high, like 10 to 12% of post-harvest losses, especially in tomato. So our target is to how we can reduce these post-harvest losses vis-a-vis the breeding and biotechnological interventions. So if you see at the processing sectors, we are highly lagging behind. Nearly 1% of our products are being processed at India level, but at the world level, more than 45 million tons of tomato is being processed as per this World Processing Tomato Council. So our challenge is very huge, how to minimize these post-harvest losses and increasing the yield as well. So if we see at this vegetable research priority, especially for this tomato, brinjal and chili, multiple disease resistance is our topmost priority in these all solanaceous crops, especially resistance to biotic stresses, and then climate resilience is the topmost priority. So at this institute level, we are also targeting vis-a-vis these sustainable development goals targets. So we are nearly meeting to these 8 of sustainable development goals like poverty, zero hungers, good health. So vegetable having this very important role. This so in brief, this molecular applications, somatic hybridization was this pioneer work which I started at CPRI Shimla, and so this was interspecific somatic hybridization using through protoplasm fusion. We could able to develop 3 somatic hybrids for the late blight resistance as well as the potato virus Y resistance. So these were the species Solanum pinnatisectum and Cardiophyllum, which were not crossable to this common species, and these are the tertiary gene pool species. And so pre-breeding work was done using this protoplasm fusion of these wild species, and pre-breeding materials were further developed, and they were also registered with the ICR NVPGR New Delhi as genetic stocks. These lines, genotypes as pre-breed materials were further characterized as molecular and cytological labels for hybridity as well as the disease resistance through artificial inoculation for the late blight resistance. So these were the 3 materials, original materials developed as a somatic hybrid, we say, through protoplasm fusions. And so now these are being materials being used in the breeding of potato varieties. These are advanced lines which, using those materials which were developed at Shimla, and they were registered also besides their original materials. And so now we are developing the varieties hybrids using these materials. So Further, adding to this as a marker-assisted breedings, these materials were also used for the development of markers and genome sequencing like that. And so we could able to identify some of the SSR markers along with these materials, where SSR played a very important roles in these lines. So these are the glimpses of different markers being used in our breeding activities, where in this SSR is one of the important markers. So as a tomato, for the tomato genetic resources, currently we are working on the breeding and genomics for the tomato, especially for the processing and multiple disease tolerance. So these are the glimpse of how the genomics tools we are applying, especially for the GWAS studies and mining of SNPs using our more 100, these 400 collections of accessions at IAVR Varanasi. So we know this tomato genome was sequenced in 2011 and 12, and currently the pan genomes of more than thousands of accessions have been sequenced. And at the IAVR Varanasi also, we have GWAS panels of more than 200 trans accessions, and we have sequenced those lines and identifying few markers for breeding. So pan genome of more than 1,000 of accessions have been developed worldwide. And various species have been sequenced in the tomatoes, and Cas marker and SFP chips have been developed for the breeding work at global level. And cutting edge technologies have been applied to these genomics tools, especially genomic selections for the complex traits like processing and especially these abiotic stress tolerance. These are the complex traits, and so we are also applying these genomic selections. And we are also working for this for the specific processing traits in tomato. So these web-based tools in tomato, these are available for the tomato different genomics tools being used to identify the markers SNP at the breeding levels also. So for the genome editing, my colleague is there, Dr. Indivar, who will be discussing more on the genome editing, especially in chili crops. So I'm not going to touch much of the genome editing tools. We are also working here at IAVR Varanasi for more than 4 or 5 crops, especially for tomato, chili, this cucumber and muskmelon. For in tomato, we are targeting for biotic stress tolerance as well as for these processing traits. So these are the few genes and candidate traits have been identified and being edited worldwide. And so multiple traits of the plant phenotype, plant architecture, biotic stress tolerance, abiotic tolerance, and fruit nutrition and quality. So these have been targeted in tomato along with other various crops worldwide. And genome edited plants have been developed. So these are the roadmaps for the vegetable crops in which tomato, potato, brinjal, these are the we are targeting, especially for the high yielding varieties, climate resilience, biotic stress tolerance, processing, value addition. So genome editing tools and genomics assisted breeding tools we are using. Development of markers and QTLs being used across the labs. Speed breeding facilities is now being it has been established at IVR Varanasi as well as the different vegetable crops institute also, horticultural institute also. So besides nutritional and quality parameters and post-harvest management is one of the key parameters. We have to look into those, and along with that, we are focusing also on input use efficiency, especially nitrogen use efficiency to this for the environmental losses, and drone-based and IT, Internet of Things. So these things we are also applying for the resource input efficiency in vegetable crops, especially tomato and other crops as well. So if we look at these strategic approaches in our crops technological integration, like AI, being everybody is now talking of AI and sensor technologies, IoT, the precision management, especially for the crop production technology, precision management is being used in our crops at institute level. Climate resilience is the topmost priority for all vegetable crops. Supply chain coordination, market intelligence, diversification is another key area of crops. Sustainable practices, value addition to minimize the post-harvest losses. And finally, the policy frameworks along with the logistic and distributions are the key features for the future management of crops. So this is all about in brief for this Besides, we are also we have been developed these tomato hybrids for the development of for biotic stress tolerance. Biotic stress tolerance, like in potato, we have developed Kufri Jamunia and Kufri Nilkant. These are the bio-fortified potato varieties. And in tomato hybrids, recently we have released these Kasi Shrestha and Kasi Daksh as a biotic stress tolerance tomato hybrids. And besides genetic stocks, they have been registered for the different traits, unique traits with NVPGR. So at the end, I would like to thank this organizer for giving me the opportunity to speak on this topic. And in nutshell, thank you very much. Thank you very much for giving this opportunity. Thank you.
Dr. Dipesh, for making such an elaborate presentation on a usage of GE in a brinjal, tomato, and all other products. I have a simple question to you, please. That is, how is this entire effort going to make the increase the shelf life? Because you just talked about the post-harvest management and you talked about the losses and distribution, and we are also focusing upon the export of the product. So how is your research is getting up towards increasing shelf life of the products so that they can be useful for our exporters also. Thank you very much.
Yes, such shelf life for especially for tomato, we are one thing conventional breeding approach we are applying to having the shelf life. More shelf life means more than at least 1 week storage is very easy for tomato, but more than 1 week storage, some good lines we have imported also from our like USA and VRDC, World Vegetable Center, Taiwan also, so that we can integrate in our breeding lines. Another tools, as a genome editing tools, we are applying for the high TSS, especially for processing and some this self-life related genes like PG and other SES genes we are editing through genome editing approaches. So these are the two techniques, two approaches we are applying for the TSS self-life management in tomato.
What about the BT brinjal? Because we have heard lots of doubts coming up about the consumption of the BT brinjal usage also. So is it going to help? Your research going to help in increasing and securing the good production of the brinjals also? Is it that possible? Because we still get a very different picture all about BT brinjal in this section.
Sir, regarding transgenics, BT, I was at CPRI Shimla. Their RB gene, I will start from RB genes, like that is for late blight resistance. It was gene was isolated from Solanum bulbocastanum, that is wild species, highly resistant to late blight, which is the dangerous, most destructive disease in potato. So those lines were also at the institute level, and RCGM has, I think, approved for the BRL1 and BRL2 trials in the that potato crop. Your question regarding the BT brinjal, it was IIVR. Currently, I'm working here, and this institute is a part of had been a part of BT brinjal, and lines are being maintained still here. But RCGM approval for conducting biosafety trials and those things, it needs a huge cost, as you know. So these are the things at our level. So at least these are at the confined field trials level, and yes, it's in progress, we can say.
Lots of information. Thank you. If anybody ready to ask one question, would you like to? Please.
Dr. Tiwari, I have a question from you.
Sir.
There is a variety in tomato, and that is developed by Syngenta. And the name of that variety is Avinash.
Yes, because yes.
The cost of Avinash is 1,90,000 rupees to 2,10,000 rupees per kg, as against the traditional varieties in India, which are hardly around 3,000 to 4,000 rupees maximum per kg. My question is, does India require such type of expensive varieties? Because they have a different claim that per plant there is a minimum of about 8 to 10 kg of tomato. One. Second, the shelf life of each tomato which Avinash is producing is minimum of about 14 to 16 days. But do India, because of small and marginal farmers, which is 1.06 hectares only, 83% are small and marginal farmers, such type of varieties are required to be promoted in India or not?
Sir, in public sector also, there are varieties, hybrids at IRI Pusa, IIVR Varanasi, IIHR Bangalore. These three institutes are working actively in tomato crop. I'm working on tomato, and so yes, varieties and hybrids are there, but our we can say weak point is market intelligence and seed chain, commercial seed production activities, especially I'm at Varanasi level, and so we know the condition of Varanasi. Our seed window for seed production is very less, and so looking for those seed production activities in southern India, like Karnataka and those areas where we can produce more and more seeds and to reach the farmers. So to reach the farmers is we can say our main lagging behind. But yes, hybrids are there. We grow the Avinas, Avilas, Saho, Sampurna. So these all hybrids we also grow at Varanasi level, sir. And we know the performance of those hybrids. But yes, to production of seeds and to reach at every village, every footstep of these farmers is our, we can so this. That's why we are not able to reach availability of quality seeds.
Hello. I would like to compliment his answer. We are good vegetable crops, and till date we have released 130 hybrids and varieties in different crops. And some of our hybrids and varieties are far better than private companies, which is evident from the fact that during last year only we licensed 65 technologies to the private industry. Some of them are big Indian companies like Indo-American Hybrid Seed. So those because of the resource problem, we cannot produce that much kind of seed. We are licensing to private companies, and those companies are taking up our hybrids and varieties, and they are selling on behalf of us environment. So through that way, we are trying to reach the farmers and each nutrient corner of the country.
Hello, Dr. Tiwari, as well as Indra Prasad. I have a question related with Mr. Kamal question. As we talk about, as you are giving the answers that our institutions like IIHR, INVR, having the lots of the hybrid varieties, but the question which has been highlighted by the Mr. Kamal, in case of the Syngenta, the Avinas variety, as I'm from eastern part of the country, West Bengal, so Avinas is really the one of the very popular varieties in the West Bengal for the farmers' point of view. And as it is cost much compared to the rest of the other companies' varieties. So my question is that if our institutions have a lot of the hybrid varieties, but why it is not popular to the hands of the farmers? Is it at the hands of for the research purpose only? Because we do a lot of work in the tomato. I'm also from the Department of the Vegetable Science. But still now, where are the hot tolerant varieties and heat tolerant varieties? Although there are lots of work in IRI, IIBRI, but can we fulfill the demand of the farmers to grow the tomato heat tolerant varieties? So that is what the simple question which arises in my mind.
Sir, as I said earlier, we do have hybrids compared to those private sectors. But yes, availability of seeds is our main drawback. Availability of quantity of seeds which can reach to those because after a release of varieties, we have to wait for the seed production. And we know at our research farm, we cannot produce those multiple of seeds as required in the country level. I know also that requirement of seeds area-wise and demands of those varieties. So production of seed production and availability of those is our main lacuna where we are lagging behind. But at the variety hybrids level, we are not lagging.
For that, Dr. Theory, as I know, there are lots of the hybrid, there are lots of the varieties of the tomato which have to develop from institution. And all over in India, that AVRDSC program or your AICP program of vegetables, why not an either every center and not giving an enthusiasm for producing the seed? Each and every center produce the seeds of those hybrids. Generally, those hybrids will be popular for the hands of the farmers of every state. But why this is not happening? The seed production program in each and every AICP center.
Yes, sir. That's why currently from Ministry of Agriculture, focus has been given to develop consortia. So we are formulating consortia, especially for potato high value crops, to develop hybrids vis-a-vis research R&D with private sectors, and so that we can reach the farmers' foot, and we can make available of our technologies to them. So consortial mode in public-private mode, it's yes, it is in progress, and we hope in future it will end up with a good outcome.
Thank you, Dr. Jagdish. Thanks for sharing your view and answering the questions. I hope anybody else, otherwise I will invite the third speaker. So thank you very much.
Thank you very much.
Now, my session co-chair, Dr. Inaugural Prashadji, please. Now you are requested to make a presentation.
Dr. Indavir Prasad, sir, he is a senior scientist at ICRAHOR, Indian Institute of Vegetable Research, Varanasi, India. He is specializing in genetics and plant breeding with a PhD in the discipline. His core expertise lies in chili breeding, genomics, and development of stress-tolerant crop varieties. With a strong integration of molecular tools and genomic editing technologies, he has made significant contributions to crop improvement, including the development of CGMS-based chili hybrid Kashi Garima and vegetable Baba bean Kashi Sampada, both notified for cultivation. Work also includes identifying resistant chili types and development of salt tolerant stock. Dr. Jagesh Tiwari, sir, please mute yourself. Okay, Dr. Prasad is actively leading and contributing to multiple high-value research projects funded by ICR, including CRISPR-Cas9 based genome editing in chili, genetic improvement of vegetable crops, and promotion of improved varieties. He has also been involved in major national collaborative projects in cotton and medicinal plant systems. An accomplished researcher, he has published extensively in reputed journals such as Scientific Reports and Scientia Horticulturally, with impactful work on genomics, genotype environment interaction, and post-harvest traits. His research excellence is recognized through prestigious awards like Harbhajan Singh Memorial Award. He also served as a visiting scientist at Dartmouth College, USA. Today, his talk title is Genome Editing in Chili for Developing Resistance Against Viral Disease. Sir, we welcome you.
फोल्डर होगा इससे शॉर्ट करूँ नीचे फोल्डर होगा
Yes. Yes, sir.
Hello. Very good afternoon to all of you, respected chair and dear delegates. My topic is today is genome editing, since the title of the conference is Recent Advances in Horticulture. And then genome editing is the one of the most recent developments in the field of biology, which has happened in recent times. As you have heard of CRISPR-Cas technology, two lady scientists, Dauda Carpentier, got Nobel Prize recently in chemistry in 2020 for this technology. So at ICR, we are having a very mega project looking at the endless opportunities in this technology in all the fields, including agriculture, medical, biotechnology. ICR sanctioned a mega project of 500 crore rupees 3 years back. And we at IAVR, we are part of this project. And by training, I'm a plant breeder. I did my PG from genetics and plant breeding from Panagar University. And I started my career with a multinational company. You must have heard of Monsanto. Then I joined ICR in 2011. And I'm working at IVR for past 7 years and exclusively working on chili. So 1 minute, just I would like to give a brief introduction about my institute. It is one of the 113 institute of ICR, which is exclusively working in vegetable crops, 44 vegetable crops. And I think it is the only institute in India which is only solely given responsibility to work on the research and development of vegetable varieties and hybrids and their production technology, as well as training the farmers how to cultivate the crop and disease management practices. And India vegetable sector success story is evident from this slide. As compared to 1951, our area has increased 4 times, productivity has increased 3.2 times, and production has increased 13 times. And per capita availability has also increased 4.8 times. These are the latest data released by Ministry of Agriculture. So right now we are producing more than 270 million tons of vegetables. So the crop I'm working is chili. Chili is a very important horticultural crops. You must be proud that India is the largest producer, consumer, as well as exporter of chili in the world. So we produce most of the global chili is produced in India. We consume also, and we are the major exporter. And among agriculture commodities, after rice and black pepper, it is the third most exported commodity. Last year, we exported around 50,000 crores of chili. So our farmers is and for our country, it is also a major foreign revenue earner. But growing this crop is grown in almost all of the country in all the states, and we have more than 700 types of chili which are being grown in India. But growing this crop is getting difficult because of few problems. One of them is virus problem. Virus problem is a major concern in most of the vegetable crops, be it tomato, chili, brinjal, potato. In most of the vegetable crops, viral diseases are the problem. So to counter this problem, to tackle viral diseases, we employ our conventional breeding techniques where we used to develop resistant varieties, but it takes almost 10 to 12 years to develop a single variety. So I joined IAVR in 2018 and 2026. I was able to develop only one variety. So it took me 8 years to develop one hybrid Kashi Garima. So it's a very lengthy process. But through genome editing, this is a technology where we can change the genetic behavior of the crop, change the gene of the crop in a couple of months, and your edited plants would be ready in 1 or 2 years, which will be ready for testing. So it is a very revolutionary technology. So our institute has developed many varieties and hybrids of chili. Before my predecessors have developed 4 varieties and 4 hybrids, which are very popular among the farmers. This is one particular variety, Kashi Animal, and it is very one of the early varieties released by our institute and a landmark variety. It's grown almost 400 districts of the country, and its impact assessment was also published by ICR that it gained almost 100 crores revenue for the farmers of the country. But this variety is old now; it has become susceptible to the viral disease. We call it chili leaf curl virus disease, which is caused by a virus called virus. And to counter that problem, we propose to employ this revolutionary technology, genomic. And for when this viral disease come, what happens to the plant? The plant growth becomes stunted. Its leaf will become very little, crooky type. There will be no flower, no fruits, and whatever you have planted, not a single fruit will obtain if there is a severe infestation. In 2021, there was a major outbreak of disease in MP and Rajasthan, and 80% crop was lost. And that year, India export also went down, and chili prices went up. Sometimes you get chili at 5 rupees per kg, but that time it went up to 120 rupees per kg. So that is the problem. It is a very sensitive crop and political crops also. A lot of protest happens by the farmers because of the nature of the crop. So we selected this crop, and the resistance was worked by a Japanese scientist, South Korean scientist, Mr. Koida, who found that in 2021 there is a gene called pelota gene. This gene contributes resistance in the chili crop. When this gene is in dominant position, in natural position, the plant will be susceptible. But somehow, if you change this gene either through conventional mean or by genome editing or mutation and bring make it recessive, then the plant will become resistant. So that's how we are trying to address this issue and this problem by targeting that pelota gene. And this is the overall summary of snapshot of the CRISPR-Cas technology. The full form of CRISPR, this is a very all the important for students also, because this is a very hard topic in all the competition exams also. What is the full form of CRISPR? So it's a cluster regularly interspersed short palindromic repeats. So it's a technology where there are some nuclease enzyme which is used to cut the DNA, and through DNA repair process present in our biological system, the DNA is repaired automatically. But you know, if our body system repairs our DNA 1,000 times, 10,000 times, there is some error, and that error process is utilized by this technology. Like all you know, our DNA sequence is having ATGC sequence in our every living cells. So whenever I cut a DNA and our body repairs, suppose there is a sequence, but out of 10,000 times or 10,000 times, there will be AAEC. So we have to just identify that cell or plant which has got misrepair, so that even if one base pair is mismatched, our whole gene function changes. That's how I dominant change to recessive. So through this technology, we try to edit the gene, try to screen the plants which are having mismatched genes, and then we test those plants in our lab and field that whether they have acquired resistance or not. And this is the whole technology. And this technology is useful for so many purposes in medical field, in biological field, and you must be surprised to know that most of the patents coming out of the biology are now based on this CRISPR technology. Yeah. It is a mutation technology only. So it is called site-directed mutagenesis. It's another name is that. And but earlier this work was done through transgenic, where we used to import gene from another non-related species. Like in BT cotton, the gene was taken from bacteria. Everybody knows. So there were a lot of regulatory hurdles. We could not release BT brinjal till date in our country, even though technology is 20 years old. So to overcome this problem, this technology has been deregulated by government of India. So there will be no animal trials. There will be no confined field trials. And after just following 2-3 years of necessary arrangements, you can directly release in the field. So because there is no involvement of foreign genes, it's our own genes which we are editing, which happens in the natural way also. Every day our genes get mutated. Sometimes we get harmful reactions if it is some life-saving genes or cancer-causing genes. Otherwise, there will be no effect. So this is the natural process which we are speeding up. So at our institute, we are working on 5 crops: tomato, chili, cucumber, muskmelon. And recently, with the government support, we have established a very state-of-the-art genome editing lab. I invite all of students and faculty members if they get a chance to visit our facility. It's a very wonderful facility. And these are the setup we are establishing. And this is the work plan where we are doing. First, we have to identify the gene, which are the gene we want to edit. So how we'll identify that gene? You have to survey the literature. Whatever work has been done in the world, you find which gene is responsible for which trait. Then what variety you want to edit, like I selected my landmark variety. Then we try to generate the sequence information. What are the ATGC sequence? It's literally we read the gene through sequencing. So my gene is 9,000 base pair. So there is a sequence of ATGC, and I have to just find out through modeling which base pair I want to change it. So this is the technology, and through CRISPR-Cas we design vectors, and then we edit the gene. In vector, there will be Cas protein and some markers through which we do the cell selection. So this is very complicated technology, but in a nutshell, I have listed out the steps what we do. Once we get the editing, we confirm through sequencing. There is sequencing mechanism called Sanger sequencing, where we do sequencing of short sequences, and we confirm the edit. So for doing the editing, the first part is how to develop a develop a whole plant from the cell. It is possible through tissue culture technique, but in chili, it is a very reconstituted crop. There is a, like tomato, tissue culture technique is very easy, but for chili, it is a very tough crop. So for the first time, we develop a novel protocol in our lab in which through plant we developed a protocol where by a combination of hormones we were able to develop plants from the leaf tissues through callus regeneration. Then after we optimize all the vector transformation, vector selection, vector transformation, and our plant transformation system. So these are the photographs, and this is the sequencing. I am telling that how we read. So the first line is our control plant. There is no editing, but in the third line you can see instead of the C, we got a edited plant which was having P. So we have to screen out thousands of plants which are having this edited gene, and then we will confirm their resistance by giving them infection either through in the field, either through artificial whitefly infection and all those things. That's how we are doing editing. And till date, after screening 1,500 plants, we were only able to get 25 plants which are right now in our polyhouse. So this is the summary of the achievement which we have achieved till date. After doing transformation in 1,500 plants, we got 25 plants, and they are editing. We are confirming through sequencing. So this is the first part of the story. But you see, for editing a simple gene, so much work we have to done. We developed 1.5 year tissue culture protocol, then all these vector transformation, then editing, then all those things. So to overcome this problem, there is a recent technology which we call RNP based editing, where there is no involvement of bacterial vector for transformation. Only you have to take the Cas protein and your guide RNA, which is a sequence which you want to edit in the plant. You have to mix it and give it to the plant, in their protoplast. So this is a very recent technology. So to learn this technology, I recently visited USA and took a training for 3 months in the very prestigious Dartmouth College, where I tried to do RNP based editing in chili protoplast. So what is the process in this novel technology, where you grow the seedling, isolate the protoplast of the system, and then you take your RNP complex, which is a mixture of your Cas protein and guide RNA, and you do transfection of the protoplast and regenerate the plant through the protoplast. Since the duration was very less, so up to the stage 4, we were able to do in the US lab. Now I'm continuing that work in our lab. So this is the snapshot of the work where we, with the help of two enzyme, mesrozyme and cellulase, we developed a protocol to isolate the protoplast from the chili leaves, and we optimized the protocol where we, after 3 hours of enzymatic digestion, we were able to get the protoplast. So these are the photographs of the chili protoplast. After obtaining the protoplast, it should be viable protoplast, not the dead. So we did the viability test also. Then after, we took a vector which was having GFP protein. GFP is a protein which gives green fluorescent signal in the plant cell. So what is the advantage of that? That you do not have to grow whole the plant to screen whether it has been transformed or edited or not. If some cells are giving green signals, you can just sort out that now this protein has gone in there. There is a marker system like that, and you can identify. So we developed this protocol, and this is the slide where live protoplasts were transformed. So in the first slide, first row, you can see. इसको थोड़ा सही कर दीजिए. In the first row, you can see there are non-transformed, but in the last row, you see there is a GFP signal coming from the protoplast. So we developed this protocol in chili, cucumber, tomato, and Arabidopsis in that lab, and we will continue this work. So these are and after transformation, we have to regenerate the protoplast in the whole plant. So we also developed a regeneration protocol where we used arginate medium for multiplication and division of protoplast, and we were able to see cell division of protoplast after 7 days of incubation. So this is the nutshell, and we are hopeful that within 1 or 2 years, we'll be able to get success in genome editing. India is the first country in the world to release genome-edited crop in the rice. Last year, our Prime Minister released the hybrid. So India is the leading country in the world which has adopted this technology from the front, and also released the rice variety. And our institute is now having very advanced work in tomato. In Chile also we are progressing, but there are some issues. So we are hopeful that we'll get success very soon. And thank you very much.
Thanks, Dr. Deva, for such an elaborated presentation and giving us so much of insightful about the technical aspects of the chili. I must add here that we at the Indian Institute of Packaging, we have got a packaging for the chilies, and we are designing and developing packaging for Andhra Pradesh, because Andhra Pradesh is the one which is having more exports for chili right now. Yeah, leading producer also. Dr. Indeva just told me 50,000 crore of exports taking place. So I will request Dr. Indeva that in case, why not this Kashi, these varieties should come to us also for packaging, so that we can design and develop packaging for their exports, their farmers also, because that is going to bring fetch dollars to us, right? Thanks a lot. One more thing, we had heard that there's a Jwala chili which is going to be used, in fact, which is being used by the ladies for the protection for the self-defense. Is there any such a scope for your chili also, so that you can also, because this is the one which is those who are not having weapons, they can use it. This is the commercial part. See, I always believe in commercial part, longevity of the shelf life of the product, at the same time commercial aspect in the industry. So these kind of things are always helpful. So scientists, if they are keeping in mind these kind of things, it will be purely helping them, helping the farmers to earn their money also, right? Thanks a lot for making such a thank you, Dr. Deva.
Okay, now we are moving towards 5-minute rapid fire oral session. The guidelines have been shared already, so each and every participant will get only 5 minutes to present their work. So in that, first I would like to call Miss Khadija Mika Daud, Department of Agriculture Science. The talk is on pot experiment on cadmium uptake by Brassica juncea and Brassica carinata.
Hello. Hello, am I audible?
Yes, you are audible. Please share your PPT and
Okay.
5 minutes with you.
Okay. Good morning, all. My name is Khadija Mika. I'm from Sharia University. My topic is about pot experiment on cadmium uptake by Brassica johnsia and Brassica carinata. On the supervision of Asutosh Kumar and Chongtam Mam. Mustard plants are effective in heavy metal uptake and tolerance. Brassica johnsia is widely recognized for strong phytoremediation ability due to rapid growth and high metal accumulation. Then cadmium is highly hazardous, originated from industrial activities, mining, sewage sludge, and atmospheric deposition.
On full screen, we are not able to see your slide.
Okay.
You are using mobile, I think.
Yes, I'm using mobile.
Okay.
Yeah.
Please zoom it so the audience can see your slide. Can you zoom your slide
Is it okay?
a bit more? Okay.
Okay.
Okay, you continue.
Okay. The study investigate cadmium uptake in both species under controlled condition with varying contamination levels. It compares the performance based on biomass, metal accumulation, and tolerance mechanism. These are the two plants I used, Brassica johnsia and Brassica carinata. Then material and methods. Pot experiment was conducted in Sharda University during winter season. The soil type was clay, slightly alkaline, and calculated, and calcareous in nature. Then the soil was artificially contaminated with cadmium chloride with an untreated control for comparison. Pot experiment conducted with cadmium levels of 0 to 50 ppm to stimulate natural contamination conditions. Translocation factor TF, used to access the metal movement from the roots to shoots. Then bioconcentration factor used to evaluate cadmium accumulation and efficiency from soil. This is the picture here is the cadmium chloride salt, and this is the me when I was when I was introducing the cadmium to the soil. Then this is the heavy metal samples after during the experiment. Then the results and discussion. Bioabsorption of cadmium by Brassica johnsia and carinata. Then the shoot biomass in both species decreased at the level with minimal impact in Brassica johnsia. Brassica carinata showed higher concentration of higher cadmium accumulation than Brassica johnsia, especially at 10 and 20 Root uptake pattern mirrored shoot accumulation, with brassica gensea performing better. Translocation was more efficient in brassica gensea than in brassica carinata. Maximum cadmium accumulation occurred at 20, with brassica gensea showing the highest uptake overall. This is the graph was plotted, and cadmium effect on plant growth. At 10 mg, cadmium shoots biomass increased by 20% in Johnsia and 62% in carinata, but higher cadmium caused growth inhibition and toxicity. Cadmium accumulation in shoot rose with increasing soil cadmium, peaking at higher concentration in both species. Strong cadmium uptake efficiency at low level with BCF, though efficiency declined as cadmium decreased, as the cadmium increased despite continued plant survival. This is the graph for the cadmium effect on Brassica gensea and Brassica carinata. Then the cadmium effect on Brassica gensea and Brassica carinata in the shoot. Then ability of Brassica gensea and Brassica carinata phytoremediation of moderately cadmium contaminated soil. Brassica gensea and Brassica carinata are high biomass, fast-growing crops suitable for cadmium phytoremediation. Both species show strong cadmium tolerance and high bio concentration, validating their remediation potential. But phytoremediation efficiency is strongly influenced by biomass with higher yield, accelerated cadmium removal. Effective field application requires proper fertilization and agronomic practices to enhance performance. In conclusion, through pot experiment, this work evaluated the cadmium tolerance and accumulation of Brassica gensea and Brassica carinata concerning their development cycles, biomass potential, and capacity for cadmium accumulation. Both species seems appropriate for phytoremediation of soil containing cadmium contamination levels less than 30 milligram per kg to heavy metals. To improve soil cadmium removal efficiency and agronomic methods, further field tests are needed. Thank you for listening.
Okay, do anyone have any question? Okay, now I would call the next participant, Miss Loganyaki Somasundaram, KG College of Allied Health Sciences, KG Hospital and Postgraduate Medical Institute, Coimbatore. The presentation title is Innovative Biotechnological Approaches for Rapid Multiplication and Conservation of RAT Horticultural Species in Tamil Nadu. You have only 5 minutes, please.
Good afternoon, everyone. I am Logan Aigi from KG Hospital and Postgraduate Medical Institute, KG Group, Coimbatore, Tamil Nadu. And today I am presenting on innovative non-transgenic biotechnological strategies for rapid multiplication and conservation of RET horticulture species. So why we selected this topic is the rare endangered threatened species. This study focused on sustainable conservation using modern biotechnology. So, RET species are rare, endangered, and threatened plants that are very important for biodiversity and medicine. However, due to habitat loss, overexploration, and climate change, these species are rapidly declining. So, we are developing non-transgenic plants, rapid multiplication, improved survival and quality. We are proposed to integrate bioreactor, metabolomics, AI monitoring, vertical farming. So for this initiative of work, we selected 3 species in Tamil Nadu. They are Laurasia superba, Pterocarpus santalinus, and Tecalipis hamiltoni. The traditional conservation methods like seed banking are slow and less effective. So modern approaches like tissue culture and micropropagation are now being used. In this study, we focused on non-transgenic methods, meaning no genetic modification is involved. Our main objective is to develop a non-transgenic framework for rapid multiplication and conservation. We also aim to improve plant survival and quality. We integrate technologies like bioreactor, metabolomics, AI monitoring, and vertical farming. These are the methodologies we used: tissue culture technique like micropropagation and somatic embryogenesis. Temporary immersion bioreactor were used for large-scale multiplication. We also applied metabolomics for quality selection and AI-based monitoring for growth tracking. So finally, vertical farming were used for sustainable cultivation. The main problem is the rapid decline of RET species and limitation of traditional method. So the key question is how to achieve fast, efficient and sustainable conservation. The first, bioreactor system significantly improve propagation efficiency. Second, plant survival increases due to photoautotropic conditions and beneficial microbes. So third, metabolomics help identifying high quality plants with important components like colchicine, aromatic compounds, and xanthalene. And fourth major point is AI monitoring and vertical farming improve growth control and sustainability. Overall, TIB system and somatic embryogenesis, a long-term germ plasma storage, photoautotropic and PGPM, integrated metabolism, and AI assisting monitoring. The integration of multiple technologies make this approach high efficient. In this, it is eco-friendly since it is not transgenic. It also supports both conservation and commercial application. It reduces pressure on natural population. In conclusion, this study provides a sustainable, scalable, and eco-friendly strategy for conserving horticulture RET species while enhancing their medicinal and economic value. It improves propagation, survival, and quality. This approach supports sustainable biodiversity, conservation, and bioeconomy development. So these are the references we referred. So thank you for all your attention. Thank you.
Okay, thank you. Now I invite Mr. Vatsal Singh Rana, Amity Institute of Biotechnology, Amity University, Uttar Pradesh, Noida. On the title is Evaluation of Bacillus firmus to Control Milledogine Incognita. You have only 5 minutes with you.
Good afternoon, everyone. My name is Vatsal Singh Rana. I'm an MSc trainee, currently doing my master's in biotechnology from MIT itself. My project title is Evaluation of Bacillus firmus to Control Milledogine Incognita. Milledogine incognita, a major plant parasitic nematode, is a microscopic soil-borne roundworm which is responsible for up to 21.3% crop loss in India alone. Approximately 10,000 crore agroeconomic loss is suffered by India due to these nematodes. Yield loss in vegetables is alone 40 to 70% in this field because of these nematodes. Therefore, and biological control agent is advised by integrated pest management to counter these nematodes. One such is Bacillus firmus, on which I'm working on. My objective is to assess the impact of this Bacillus firmus against incognita under in vitro and in vivo conditions. Methodology. The strains of Bacillus firmus were revived and cultured in nutrient broth under suitable conditions. After that, the nematodes were collected from infected plants, and the egg mass collection was then transferred into healthy plants. After 1 month, the new larvae were collected and later taken for biosis in vivo and in vitro conditions. In vivo conditions, the um, collected uprooted root nodes of the plant were grinded in a blender along with water, which gave us a semi-solid water, which was filtered then using Baerman funnel method, which gave us J2 juveniles of nematodes, which were inoculated into healthy plants. Uh, the Bacillus strain, which was previously revived, was diluted into requirement samples, which were after 5 days treated into the infected plants. After 10 to 20 days, the mortality rate of the nematodes was counted. Uh, and in vitro conditions, the same nematode extract which we previously extracted was utilized in a tissue culture plate. Uh, Approximately 1 ml of this solution was introduced into each well, and 100 microliter of Bacillus strain sample was introduced, after which 24, 48, and 72 hours later, we can access the mortality index of the strain on these nematodes. In vivo assessment of Bacillus firmus, we can see that the 50% concentration showed the highest mortality peak, after which 75.2% most population was dead. Another promising mortality percent was then introduced 20 days later in the 10% concentration. In 10% concentration, there was a striking increase in the mortality after 20 days. In vitro assessment of Bacillus firmus. The highest mortality in this case was achieved after 48-hour mark at 10% concentration, which shows 50% mortality, followed by 47% mortality after 24 hours in the same concentration. 50% concentration showed a consistent mortality rate hovering between 46 to 47% across all time zones in 24, 48, and 72 hours period. The conclusion of my result is that the Bacillus firmus revealed a promising potential as an effective microbial antagonist for the suitable management of M. incognita, and further validation in field conditions can further improve it, so that we can implement it in ecological and agriculture and industrial scale, so we can help the farmers achieve uh, a cost-effective, user-friendly, and readily accessible alternative for chemical nematicides uh, for sustainable agriculture. These are the references. Thank you.
Now it's time to conclude session 1 here. I would request Dr. Pragya Barua, Biocare Fellow, AFAF, to kindly deliver vote of thanks.
Good afternoon, everyone. As we conclude this enriching session on breeding and biotechnological innovation in horticulture, I would like to extend my heartfelt thanks. First and foremost, I express my sincere gratitude to our esteemed chairperson, Professor Shailendra Kumar Dubey, for his excellent leadership. A special thanks to our keynote speakers, Dr. Javeli, for his inspiring talk, enriching our understanding and settling a remarkable tone for the session. My heartfelt thanks to our invited speakers, Dr. Jagesh Kumar Tiwari, for a thought-provoking and impactful presentation that has greatly benefited us all present here. Dr. Indivar Prasad, for taking the time to be present with us in person. Your presence has truly elevated this session.
A big thank you for all the rapid fire presenters. Thank you all for your contribution and active participation. Your insights and research have made this session truly invaluable. We look forward to future collaborations and advancements in horticultural science. Thank you.
Now I would like to request Dr. Nutan ma'am to kindly felicitate our session chair, Dr. Dubey sir.
One party is there and second party good. Thank you.
Oh, sure. Thank you. Thank you. Thank you so much. Thank you so much, sir. We will definitely would like to further take this our relationship further to form a MOU and so on. Thank you, sir. Thank you for joining. Just check.
Dear audience and respected dignitaries, we shall now break for tea and the session will commence at 4:45. So please kindly join us on time. Session 2 will commence at 4:45. Please join us on time. Welcome back, you all. We now move ahead to session 2 on digital horticulture and smart farming. This session will be highlighting how digital innovations are helping modern farming systems. To carry forward the session, I now invite session coordinators, Dr. Sachin and Dr. Arpita Bhattacharya, to kindly take over the session proceedings. I would also like to invite our rapporteurs, Dr. Chitranjan and Dr. Payal Chakraborty, who will be documenting the proceedings of this session.
Thank you, Dr. Gautami. Good evening, all present here. In this session, the theme of the session is the digital horticulture and smart farming. This is actually the utilization of the new technologies into the cultivation of the horticultural crops to improve the productivity and also to maintain the quality. In this session, we have 2 keynote speakers and 2 invited talks, followed by the rapid fire session, which is oral presentation. And for this session, the session chair is Dr. Umesh Thapa. This is my privilege to introduce our session chair today. He is the professor and former director of the Extension Education, Department of Vegetable Science, Faculty of Horticulture, Bidhan Chandra Krishi Vishwavidyalaya, Mohanpur, Nadia, West Bengal. He completed his BSc, MSc and PhD Horticulture from BCKV. After that, he did his postdoctoral research from Italy. His main area of interest are protected cultivation, hydroponic, soilless vegetable production, vegetable grafting, stress tolerance, and underutilized climate resilient vegetable crops. He has published more than 1,000 research papers, edited 28 books, and author of many articles, bulletins, and practical manuals. He completed 18 projects and currently 3 projects are ongoing. He is the PI of All India Network Research Projects on onion and garlic. He guided many PhD students and supervised several postgraduate theses. He is associated with many research organizations and universities, and he has a great network all over the world. So I request Dr. Thapa to come to the stage and just share few thoughts on this conference. Thank you, sir. Just joined.
Yeah.
Is that
Hello. Hello, good afternoon to everybody. And today I'm here as the chair of the section of digital horticulture and smart farming. First of all, I would like to thanks for giving this opportunity to me as a session chair as well as the keynote speaker for the tomorrow's session. I like to give more thanks from my inner core of the heart to Madam Kaushik. So, and today in these sessions, which I feel is one of the important sessions, that is digital horticulture and smart farming. So, first of all, welcome to all the delegates who are in online and offline, as well as all the scientists and the respective faculties of these institutions and the dear participant. Today in these sessions, we like to know the better in the present field of horticulture. Being a modern technology of the horticulture, now we feel that this digital technology and the digital techniques and the smart farming becomes one of the future technology for the horticulture development section. As we know, through the digital inputs like precision farming, remote sensing, and show others IoT, AI, these are the new future generations technology for the future generations, students like you. So I hope in this session, I'm more confident that we came to know lots of things which is related to this digital agriculture and smart farming, the researchers, as well as some of the scientists, and as well as some of the keynote speakers will definitely gives us the more good suggestions how to implement this technology for the benefit of our country, to the farmers of our country who are living nearby the cities and the urban areas, as well as this type of the technology with the botanic agri farming is becomes one of the major technology. So let's us have our first speaker of this session. We'd like to welcome our keynote address by Dr. Christine Liss. She is a senior researcher, plant health, university and research of the Netherlands, and she's in online. So we can narrate briefly about
Dr. Lee's is the research focus is on the host plant resistance to pests and diseases in greenhouse crops. She is expert in pest management. Her PhD is in biological control of weeds with fungi from University of Freiburg, Switzerland. Some of her expert area are design and implementation of the sustainable and resilient cultivation system in ornamental vegetable and bulbs. Valuable, there are volatile detection, airborne spore monitoring, and use of electrophysiological sensors. So with this, I request Dr. Lees to start her talk. Thank you.
Dear Kristen, thank you so much, and sorry for waiting, making you wait for long. Sorry.
No problem. Good afternoon to you all in India. I'm very sorry that I could not join you in person. Today we have it about technology in horticulture, but thanks also to increased technology in communications, I'm able to join you online, which is nice. My sincerest acknowledgements and thank you to Nutan Kaushik and the scientific committee inviting me to this keynote. One of the focuses of my research is indeed plant resilience. And having looked at the program, which I got around Easter here in Europe, I thought, ooh, I have 15 minutes, so I have to be quick. So I have to admit I shortened my presentation quite a bit, and now I have to stick to that. Anyway, I will try to share it. Let's see. Can you see my presentation?
Yes, yes, ma'am.
Okay, then I go into the presentation mode. Okay, right? And then I will try to minimize this. Okay, right. So as I said, the focus of my research is plant resilience. So the title of my presentation today is about the role of plant resilience in sustainable horticulture. And within Wageningen University and Research, I actually work in the business unit of horticulture. And in the Dutch terms, that means actually only indoors in the greenhouses under high technology. Just to give you the background, as most of you will know, the plant cannot run away once it is attacked by pests and diseases, but it has developed an intrinsic own defense system. So if we look to the right, if the plant is attacked by an insect or by a necrotrophic fungi, like for instance botrytis, then it actually increases signal hormones in the plant to tell the plant parts, I am attacked. And in that case, for the insect and the botrytis, this is the jasmonic acid. But if the plant is attacked by a biotroph pathogen, like for instance powdery mildew, it will activate the salicylic acid defense pathway. That can be locally just on the leaf where the pathogen actually attacks, or it can be systematically spread throughout the plant, which is indicated by these different colors, arrows. I mention it to make the picture complete. It now seems very black and white. Of course, there are more phytohormones, but these are the two main ones. There's a third one, which is a little bit more complicated, that's ethylene, because it's gas. And that's mainly linked to defense related to the microbiome in the soil or to the plant roots. Now, I research mainly above ground, so I will not tell you much about the microbiome, but I want to add it here to complete the picture. So how can we use this defense for a resilient cropping system? So basically, what I mean with that is, how can we use the induced resistance of the plant? And as researchers, what we do, we basically challenge our plants with different concentrations of these two plant hormones, jasmonic acid or salicylic acid, and see indeed whether the plant increases its defense against different pests or diseases. In this case, I've worked a lot with strawberry. So we applied once 1 millimolar methyl jasmonic acid to strawberry plants in the nursery. We left them for a week, and thereafter we did different bioassays with different insects and mites, including Californian thrips, spider mite, whitefly, that's the greenhouse whitefly, and the buckthorn aphid. We used 3 different strawberry varieties, and you see whatever we do here for the trips, with the application of methyljasmonate, trips damage in all 3 strawberry varieties is significantly decreased. We have a similar picture here for spider mite as well as for whitefly. In both these insects, methyljasmonate application significantly reduces reproduction. Now here for the aphid, you see that looks a bit strange. Whenever you have worked with aphids, you know they are very peculiar to work with. So this one only wanted to grow on one variety. So we only have this one blue bar. But even here you see that application of methyljasmonate significantly decreases also the number of aphid individuals. Now, that was very nice, super nice result, but that was one application. So if we are then continuing in a cropping system, and that's what we've done thereafter in strawberry, this is a much longer time scale, of course. So here again, we have strawberry, one variety. We did it for nursery and now as well as for production. So we have here more than 30 weeks of a cropping cycle. So we first did a preliminary experiment by which we tried to find out for how long is one application of jasmonic acid actually effective. And that turned out to be around 3 weeks. So what we did is we actually treated our strawberry plants starting in the nursery throughout the whole of production every 3 weeks with 1 millimolar methyljasmonate. Now, what can we see? One thing is very evident here. All of a sudden at week 9, trips damage really peaks. And that is because here the strawberry plants start production, meaning they are going into flower, they are assimilating much more, they are producing more sugars, and that's what the trips like. What is more important, you see throughout almost the whole cropping cycle, you see that the yellow bars with the methyljasmonate application are significantly lower than the control bars, showing, yes, we can effectively decrease the trips damage almost throughout the whole cropping cycle. However, this stops around week 25. Meaning the older plants we cannot induce anymore. So also that was, of course, a very nice result. What is very important to the grower, however, is the following. We usually argue that induction of plant resilience costs energy to the plant. So we would expect that somehow the yield of our treated strawberry plants should be lower. Now, this was our result. This is a production over the whole production cycle of class 1 strawberries. We also did that for class 2 strawberries, class 1 of the best quality you have, but also for the class 2 strawberry, the picture was the same, and we do not see any decrease in yield with the methyljasmonate applications. I don't show further results here because of time, but we also looked at quality of the fruits, shelf life, as well as taste. And also there, we did not find any differences between control and methyljasmonate. So those are very encouraging results. However, coming shortly back, up to now, I showed you mainly results on the jasmonic acid pathway. Just one example here also to show you this works also for the salicylic pathway. So this is gerbera and powdery mildew. And you see here, we have to increase the concentration slightly to 5 millimole per liter. But you see also here a quite nice effect of salicylic acid application on decrease of mildew. But you see here, it's dependent on the variety. In orange, we have silver snow, this one, and this seems to be not so susceptible to mildew anyhow. So also the reaction here is not really significantly different. But if you take Lido, which is very susceptible, you see that application of salicylic acid significantly reduces mildew, even strongly as this chemical fungicide Insimo. But then, of course, a plant is never alone. So we have a whole crop in a greenhouse, and there are many different factors which may influence our plant resilience in the greenhouse. This may be light factors, be it sunlight, be it LED lights. It may be, as I already showed you, the plant development stage or age of the plant. I already told you the older my strawberry plants were, then I could not induce them anymore. It may be dependent, as I showed you right now with the Gerbera, on the variety. There may be differences in the climate, so relative humidity and temperature of the greenhouse. There may be differences related to nutrients, so to the fertilization regime, and even to the substrate. So that may be soil, or in many plants we grow in the Dutch greenhouses is actually rock wool. So I want to show you two more examples how these factors, especially nutrients and substrates, may influence our resilience. So this is nutrients. It's more from the background, of course, from the Dutch growers. Many Dutch growers, I have to admit, give a luxury fertilization of nitrogen, which is not really necessary. It's a little bit the argument, the more nitrate I give, the better. However, that's not always the best for the environment, because then the excess nitrate not taken up by the plant leaches into the groundwater, which in the Netherlands is never very far away. So here we did an experiment by actually decreasing the nitrate fertilization. So 19 is usually the reference, that's more or less the standard used in the Gerbera cropping. And we went down up to 2 millimolar, which is, of course, very scarce, but we wanted to see how the plant reacts. And you see very nicely that starting here by about 5 millimolar, that the mildew very steeply decreases. Now, as I told you, we usually say, also we did not find that in the strawberry over a long time, that inducing plant resilience will cost the plant energy. So we did also this experiment with a high nitrate level and a low nitrate level. We added salicylic acid. And then you see, according to theory, at the higher nitrate fertilization level, indeed, we can reduce mildew by adding 5 millimolar per liter salicylic acid. But if you give less nitrate, so less energy to the plant, this effect actually disappears. Then substrate, it's also for us very important to know, can I actually increase my plant resilience on different growth substrate? This is an example from a tomato and trips, applying 1 millimolar methyl jasmonate. You see in blue rock wool as a substrate, and in green is actually cocos peat. And you see in both substrate very nicely, we have a decrease in trips damage compared to the control. Here we even went a step further and did a metabolomics analysis. And you see very nicely, doesn't matter which substrate we look at, rock wool or cocos, it's always the bar in yellow, so methyl jasmonate, which actually increases the following defense compounds against trips. It's quinic acid, which is a phenol, trigonelline, which is an alkaloid, and tomatina, which is an alkaloid as well. So far so nice. Then we had to go one step even further, because it's not only that you grow the crop in the greenhouse. Of course, you have also to incorporate your elicitor into a whole resilient cultivation system by which you use different integrated patch management or crop management techniques to come to a whole system. And I have to say, this is one of my favorite projects I've ever done. It was an 8-year-long project financed by the Ministry of Agriculture here in the Netherlands. So it's based on 4 pillars and or columns. And in the beginning, for the first 2 years, we were experimenting with these 4 different columns individually. And thereafter, 6 years long, we actually combined all these different things to a whole system. And I can tell you, you think you do the same every year. Every year is always a little bit different and has its own challenges. Now, let's look shortly into this columns. So one of the most important ones and one of the most revolutionary ones we called hygiene is actually that we started strawberry from seed. That's very unusual, at least 8 years ago. Usually we do strawberry from cuttings, but as you will know from other crops starting from cuttings, very often in the nursery with the cuttings you bring in pests and diseases already. So we started from seed. 8 years ago, there was only one breeder here in the Netherlands actually supplying strawberry seeds. We are 8 years further, and we see all the big strawberry breeders now do strawberry from seeds. Then obviously we put the nursery and the production all in the greenhouse. You have a protected environment. You keep the good guys in and hopefully the bad guys out. Here we have our robust varieties. I just told you we started from seed. We now have more varieties, but it's still not as much as you would have to choose from if you would use cutting. So here we actually used our elicitors to increase plant resilience. We tried to use the best growth conditions, so we set up a strawberry cropping system on rock wool. That was very new, but optimal for water and optimal for nutrients. And then we also tried to make an environment which is not very favorable for pests and diseases, but very favorable for natural enemies. That's what you see here on these 3 small pictures. Here to the right, we have so-called banker plants. With the natural enemies, it's very important that you have them in the greenhouse at the right time to get no time lag. So we have these beautiful banker plants, also looks very beautiful, in which we keep the natural enemies, in which they reproduce, and once the pests appears in the crop, they actually fly from the banker plants into the crop. And the other system which we build up is to use UVC against mildew spores. UVC can kill the mildew spores in the air. It's purely preventative. And we did that for the nursery on the tables as well in the production in the gutters. So that's a beautiful system we have now. We also see that the growers really implement this into practice. All of them is too much for them, even in the Netherlands, but we see that they pick up those elements they think fit best into their growing companies. But what is still crucial, I'm talking all the time about plant resilience, but actually the grower still does not have any real-time measurement of plant resilience in practice. We can only indirectly measure it, and we always need a lab. As I showed you, we always do it with bioassays. We have all the pests and all the pathogens we do bioassays with. We have protocols for that. We can also, of course, measure the concentrations of plant hormones or downstream the enzymes or proteins or even the plant metabolites. Now, that's very costly, actually, and also sometimes quite complicated. We can also do gene expression. Fine. That's all nice for us researchers, but nothing for the grower. So how do we get there? Now, the idea is to do that with electrophysiological sensors. And for this, I hope this works. I have this small video. So you see appearing, I do it again, if that works. Yeah, you see a caterpillar. That caterpillar is munching on a small Arabidopsis plant. And the moment it does that, with fluorescence dye, you see these very light streaks. And these are actually kind of is an electrical flow. Those electrical flows are very specific according to the biotic stress you apply. Yeah. And we actually work together with that, with the company Vivent Biosignals. They have developed a sensor here with 2 electrodes, which is fastened to the leaf and to the stem of the plant, in this case, tomato. And then with very controlled experiments, for instance, you have a control group which doesn't get anything. You have your treatment group to which I, for instance, add 5 trips per plant, or which I can infect with an exact amount of spores. Then we measure the signals of the plants, and by actually comparing those signals, we hopefully can identify the signals linked to trips or the signals to mildew or other pests and diseases. Yeah. So basically you measure the signals in millivolts. That's what you see here. And we have to do many data runs to actually be able to analyze these signals by machine learning and then come to a model for early detection. And for trips, we are already quite far. You see here in the above graph, we usually do 2 weeks of baseline measurements. Here on 21st of August, we added the trips, and you see very nicely here, the signal here for the trips is very much different than that of the control here in green without any trips. Now, with this system already, we can predict the trips. I usually now do experiments by which Vivent does not know which plant I infested with trips and which one was control. And with 75% correction, they can tell me which plant was the one with trips or not. Obviously, this still needs some optimization, but it's not bad. Now, the idea is to use this electrophysiological sensor system to actually measure plant resilience in real time. And then what we want to do is to use a range of different concentrations of jasmonic acid or salicylic acid, apply those to the plant, and hope to find the related signals, the related electrophysiological signals associated with these plant hormones. If we can define those signals, then we can carry on testing products which are on the market, which actually say they can improve plant resilience. However, we still have to, it's a very new project and we still have to execute that. But I think it's very interesting. And then to come to an end of my short presentation is, I hope I could show you plant resilience is mainly a preventative concept. There are very generic concepts like the salicylic acid or the jasmonic acid, but depending on the host plant you are working with and depending on the factors in the greenhouse, you may have very variable results. And the third one is it has to fit into an integrated pest management system. And with that, at last, I was invited to give this talk, which I really very much like to do, especially if you have so many nice results. But this is not an effort just by myself, but of a whole team. And I would like to thank them for their dedication. And thank you for listening. And are there any questions? And I think if you don't mind, I will stop sharing because then I can see you again.
Thank you you, madam. You have such a wonderful presentations which you have highlighted. You really have very clearly emphasized the importance of the crops that can be withstand with the biotic as well as biotic strengths, as well as by maintaining the productivity as well as the quality. So clearly it has been highlighted like the salicylic acid is found to be beneficial for reducing the nitrate of the plant itself, and as well as you highlighted the different substrate of the media which you are using in under your glass houses or the protected cultivation. So these integrations of the resilience with the modern technology and the sustainable practices is indeed the need of our present scenario. The presentation has not only enriched our understanding, but also inspired us to think how this type of approach can be both for the productions, productivity, and quality of the horticultural crops. So once again, I'm thanking you. And just I have a small query regarding the different salicylic acid with a different substrate which we are talking about under the protected cultivation or the glass houses. My question is that is it feasible in the open conditions when the plant is reduced by the nitrate content? Say, for example, most of the leafy vegetables which are having the more nitrate content. So if this practices has been adapted in the open field condition also, is it feasible? This is my simple questions to you, ma'am.
Let's say in general, it should be feasible. Like I said, it's a generic concept. Yeah, whether you take a tomato in the greenhouse or you grow the tomato in the field, it should still work. It's just that we focus on greenhouse crops, so I never tried it. The only thing, the closest I got to the field crops is that I worked with tulips. Yeah, I mean, very Dutch. The tulip bulbs, that works nicely. Also for application, now we use salicylic acid, for instance, application on bulbs against fusarium. And fusarium is a very big problem in the storage of the bulbs. There again, we have a different problem because the growers don't want to have their bulbs to get wet. Yeah, they don't like that. So we are looking at the moment kind of steaming bulbs or some other way of application. The other thing I tried, that was the closest I got to field crops, was potato, but in the greenhouse. Yeah, sounds a bit strange, but we actually cultivated potato in pots in the greenhouse, and even there, that principle works. Yeah.
I have now questions from the Madam Kaushik.
Thank you, Christian. Very nice presentation and very applied work actually.
Yeah.
So that's the beauty of your work. I have two questions. Maybe the first one during your presentation. How did you apply the salicylic acid and methyl jasmonate, the method of application? And if we really have to apply in the open field, how we can do it? Secondly, did you also measure the Brix value?
Yeah, let's start with the first one. We spray it, Newton. Yeah, we use it like a spray. So we dissolve it in water, sometimes a little bit mixed with ethanol. Yeah.
Which worked actually, the concentration which worked very well. The concentration of the salicylic acid and the methyl jasmonate.
The concentration, you said? Yeah, well, but we only do that for experiments, right? So for jasmonic acid, we use around 1 millimole per liter, and the jasmonic acid usually a little bit of higher, 5 millimole per liter. But be aware, I don't know about India here, but in Europe, jasmonic acid and also salicylic acid are not registered as pesticides. So the grower cannot really use it. Yeah. So we have to go a little bit indirectly through pesticides which claim, or natural pesticides, biocides, which claim that they actually activate the salicylic acid or the jasmonic acid route.
Qualify the biostimulant category?
I can't hear you, Newton.
Qualify the biostimulant category? Biostimulation.
Yeah, but biostimulation is always still a little bit different with us. Yeah, it's a gray zone. I mean, biostimulates is usually more compounds which stimulate the growth of the plant, not so much the defense. The moment you have compounds which actually activate the plant defense, we have to register those as pesticides.
Thank you so much.
Yeah. And you had one more question about the bricks. Yes, we measured the bricks. There was no difference.
Ma'am, anybody from the audience? Any questions? No, if not, then we move to the second speaker. Thanks once again.
Thank you so
very
much, Kristen. Thank you.
Thank you, and enjoy the rest of your symposium. Bye-bye.
Bye-bye. Our next keynote speakers is Dr. Gautam Das, Senior Lecturer in Agri-Robotic at the University of Lincoln, England. He will speak on robotic and AI for improving resource efficiency in agriculture. I'd like to request Rafika.
Good evening, all. Dr. Gautam Das is a lecturer in agri-robotics at University of Lincoln, England. Yeah. Good evening, sir. Let me introduce yourself. Dr. Gautam Das is a lecturer in agri-robotics at University of Lincoln, England. He worked as the assistant professor at Amrita Vishwavidyalaya, India. He also worked as the research associate in Ulster University, UK. Basically, he is graduated from Calicut University in India in the field of instrumentation and control engineering. Master degree from electrical engineering from IIT Roorkee. PhD in computer science with research focus on multi-robotic coordination and cooperation from Ulster University. His research area are autonomous field robotics, precision crop management, and robot learning. Welcome, sir. Now you can start your talk. Thank you, sir.
Thank you. Let me share my video first. Hello. Can you all see the slides? Yeah. Good afternoon, everyone. This talk is titled as Robotics and AI for Improving Resource Efficiency in Agriculture. That was the title I gave, but I will cancel that to horticulture because all the conference is about horticulture and the content I curated to horticulture. Just to introduce myself, I am Dr. Gautam Das. I am a senior lecturer in agri-robotics at University of Lincoln. I'm affiliated to Lincoln Institute for Agri-Food Technology and also to Lincoln Center for Autonomous Systems. Just a brief introduction about Lincoln and Leard. Lincoln is in the East Midlands area of England, or UK, and on that UK map there is that red region there on the slide. That is where Lincoln is. The main campus is right in the middle of the Lincoln city, but Leard is based at Riceholme. It's just 5 miles away from the Lincoln city. It's a very beautiful campus of 200 hectares with a lot of agricultural facilities, mainly test sites, polytunnels, glass house, arable fields, cattle, etc. It's mainly a research-focused campus, so some part of that campus is on the right side, and we are our offices are in that nice building in the middle. So that is a nearly 400-year-old building once it used to be the summer house of Lincoln Bishop. The research at Liat is focusing on mainly these three core areas. How we can bring robotics and AI techniques into agri-food to bring efficiency there. And also, it's not just bringing the technology there. We have to look at the policy, the changes that we need to bring to the regulations, the policies, how this technology would affect the humans, the workers, farmers, etc. So we have a highly interdisciplinary team looking into all these aspects. In the middle, that figure is showing two strawberry polytunnels there. The polytunnel that you see at the back is actually replaced now that there is a glass house at the moment. So again, this talk is a sorry for the interruption. There is a fire alarm. Just I will try to sort that out. Yeah, that's okay. Thank you. Again, this talk will be looking at a research portfolio across LIAT. So rather than looking at my own research. So when again, the focus of LIAT is mainly at UK horticulture, and it is actually a privilege for me to present LIAT at this conference, and really big thanks to Amity and Professor Nutan to invite me to this conference. When I signed up, actually I was ready to do a presentation at maybe 5 a.m. in the mornings, but yeah, thank you for the timing as well. So perfectly, yeah, in the around noon, that's perfect timing. Okay, let's go on with the slides here. So UK, it's temperate climate. So year-round production is not possible, and if we need that year-round production, we need protected environments like glass houses, etc. But again, that will all add up to the cost. You need fuel to heat up everything. And looking at that one, actually, UK has a high reliance on imports. It's more than roughly 53% as per the latest statistics from 2024. And again, the recent political situations across the world has increased the fuel cost, etc. So fuel, fertilizer, all costs are going high. So these all are actually causing a sharper inflation in the horticulture area. So nearly 38% drop has occurred from 2023. And it remained the same from 24 to 25. I mean, the didn't go further down, but still stays there. And UK was going through a Brexit, so it was coming out from European Union, and along with that, when there were many policy changes, and because of this seasonal production, UK was reliant on seasonal migrant workers from abroad. So that is again challenging at the moment. So in this talk, I will look at different aspects that will come in horticulture and just highlight some of the research happening at LIAT. So here in this one, I'm talking about soil health. So that is the base of everything. So we need soil as our medium for agriculture. And the health of soil is very important, like nutrients, soil biology, the soil texture. They all are highly important factors in the getting uniform crop growth, yield, etc. And so currently the measurements are very low resolution, like you collect some samples from a field, maybe a few samples, you mix them all, send to a lab, you get the result as a single reading for that whole field. So we are trying to move away from that one to a higher spatial resolution measurement using proximal sensing. So the robot platform there, actually, we have a project called High-Res Soils. So on that platform, we had a couple of sensors. So carbon flux measurement tool and also a soil core extractor attached to that robot. So the advantage is you can actually collect samples from at very high spatial resolution. So if we look at the carbon flux measurements, each reading can actually inform us where is the best location to go and collect the next reading. Then comes, once the soil is sorted, then comes what types of varieties we need there. So plant breeding is an important factor there. So in the past, this used to be a really long process, taking many years to identify the right varieties with the right sort of features that are attractive to the farmers, the market, etc. When it comes to horticulture, there are certain products that are really influenced by the quality rather than the quantity. So tomatoes, strawberry, apples, so you buy when they are tasty rather than when they're cheaper. So the quality is valued more here. So we have to look at the right breeds that will be suitable for the environment, resistant to different pests and diseases, ease of harvesting, so and plenty of other features as well. But again, due to the long nature of these things, we often miss many features. So what we are trying to do is actually trying to visually detect certain features from the plants, and then can we speed up that process. So here actually on the that graph shows certain features that can easily identifiable using computer vision techniques, particularly for strawberry productions. So here flowering location, number of runners, the vigor, truss, peduncle length, etc. So these all are important factors to find out the right braid that is suitable for easy picking. So for example, the if the length of the peduncle is long, actually it is easier. It will be hanging down on a polygonal table, and it will be easier for a human to visualize, see that one, and pick that easily, or a robot to reach that one. And once we have the right breed of plants there, the next thing is, once the plant is growing, how do we care those plants? So on the left end, actually, there are some diseases that we had in the past in our strawberry polytunnels. So many of these things actually are visually identifiable, means when humans can see them, it might be too late. So after that, the control wouldn't have much effect. Whatever control action that we can do wouldn't have much effect. So the powdery mildew, etc., can have huge loss of yield for a farmer. So the main thing here is actually, can we identify them even before they become visible to us? So in one of these projects that we used hyperspectral imaging to look at the right frequencies that will show these changes in the plant much before they become visible to us. And the next one with that light, that is a robot doing UVC treatment for powdery mildew. So instead of, so they are actually commercially doing this in the UK at the moment. So some fields, they are regularly applying UVC at really high intensity instead of spraying fungicide regularly. So the quality of product that we get through that one is really better. And the last figure is actually an aphid count. So can we measure the pest intensity in that field? So here in that one, the counting. So usually the density of how many pests are detected in that trap would be an indicator of how much possible problems are there. So this one uses computer vision techniques to count those aphids on those traps. Once we have the proper crop care done, then it comes to yield estimation. How much yield are we going to get? So this is much different from arable farming. So where you get one single yield at the end. So when it comes to horticulture, we have regular yield variations. You need to harvest fruits regularly. So we are in this particular figures that we have I have shown here is strawberry yield estimation. So again, there is a frame mounted on a mobile robot there with 3 robots. So I have circled those locations of those cameras with yellow circles in the middle figure, and they can look at the same sort of strawberries from different angles. So they can that can actually help to detect those ones really. They can miss. So using trial iteration, actually, we can identify we are not actually thinking this fruit as another one, or maybe from some other angle, the color could be different. So all those can be sorted. So this work was mainly done by Raymond Kirk, and after his PhD, he went on with a spin-off called Fruitcast. So it is valued in millions at the moment, and they are offering this yield forecasting service to UK farmers at this stage. And yeah, once we have predicted the yield, so that can also help with the wastage reduction, etc. But how can we harvest? This is really this harvesting part is really human dependent at this moment, and the farmers are actually struggling to recruit laborers to do this one. Earlier, it used to be East European people used to come from East European countries. Now they are not coming after Brexit, so they are recruiting from many Asian countries these days. But here we have a strawberry harvester to pick strawberries. But the challenges are they are not really as fast as a human worker, and they cannot reach all the fruits. So that is a main challenge. Another thing is all these detection techniques are computer vision techniques, deep learning. They need a lot of computational power. If you have those high power machines on the robot, the battery would be die out soon. So another option is actually, can we offload that computation to an edge server in the field itself? But that will require a high bandwidth communication in that environment. That is a challenge in the UK. If you go to remote areas, there is no network connectivity, even in UK. But when we look at all those things, all those technologies are deployed on a mobile robot platform. So we need a robot that can move autonomously across that environment, that challenging environment that keeps changing every day. So that navigation autonomy is a key thing, but we need not one, many of those robots. And again, how we can make sure they work as a team. So my main research goes into that area. So here, what we have tried to do is actually we have come up with a spin-out called Java's just another build of autonomy stack that looks into fleet coordination as a service. So we can actually support different types of robots as and provide this fleet coordinator as a plug and play service. So you can deploy a lot of robots into the field with the right technologies, sensors, actuators mounted on them. So not having such a mobile robot platform has been a major challenge with many startups in this domain. So they had the technology, camera technology, but they couldn't deploy on scale in the field. And again, with these technological changes, the workforce for the future is going to change. It's going to be a skilled labor in the future, so they all need technical knowledge and in the future. So there are technical skills that are required, non-technical skills, and networking skills, a lot of other aspects as well, connectivity, cybersecurity, a lot of aspects have to be addressed to improve that adoption rate. So the technology is at early stage at the moment. The farmers are not really attracted to many of these things because of low return of investment. And again, they are a bit fragmented at this point. Each manufacturer, technology manufacturer will have their own technology that won't communicate to another one. So open standards, etc., will be very critical going forward. And in the future, we could think like robots and humans should be working together, more robots and less humans, because the robots would be autonomous and they could do all these tasks by themselves. A possible scenario would be like a robot team going and picking fruits as much as possible, and then there would be some fruits that they cannot reach, so the human workers can go and get all the unreachable fruits. So that will be sorted. And how a future task actually would be to manage such a human robot team and allocate tasks to them. Just to recap, so just looked at soil health, plant breeding, crop care, yield estimation, harvesting, autonomous robotic fleets, and future horticulture workforce. So that were all the components that I looked at. Just as an acknowledgement, funders, different UKRI arms, Innovative UK Research England, EPSRC, Ceres Lencam, and many researchers who contributed to the previous slides, and other industry partners who collaborated and fund my research. Thank you for listening. Happy to take any questions.
Thank you, Dr. Das, for your excellent keynotes, which I can say. So in your keynote, you talk about the robotics and AI for improving the resource efficiency in horticulture. You have clearly demonstrated how advanced this technology are transforming the way we manage our crop and resources. You talk about the crops, you talk about the soil health, you talk about the yield estimation, as well as you talk about the robotic harvesting. Really, I feel that these innovations are indeed the paving way for the smarter and more smart horticulture in the future. So, once again, I just have a small queries to you regarding this technology. As you are doing your research in abroad, like we are in the India. So, in the prospect of the India, I would like to ask one question to you. That is, how do you see the role of AI and robotic evolving in horticulture over the next 5 to 10 years, especially in the developing countries like our India?
Yes, that was somewhat the same question I had when I started in this domain. The labor is still comparatively cheaper in India, so we still have humans, but again, human workers there. But over maybe the next 5-10 years, that scenario might change. More and more people would want skilled. I mean, they would need better education, and then would be looking at how they can use this technology and improve the efficiency, reduce the environmental impact. That is another major thing in India. So, and again, us like we have all these LLM models running at the moment. Everyone uses that one. So once the technology becomes as accessible as that one, it's going to make a big change. It wouldn't take that many years. It can happen just like that one.
Thank you.
I have. Thank you. Thank you, Gautam, for such a wonderful presentation. And thank you for accepting our invite. I just want to know one thing, like as Dr. Thapar has already asked, like in Indian context, how do you see it? But my question is that how does it compare? Like you are using the robot for different applications, like disease and diagnostic and spray of the pesticides and some like labor-oriented work, which is and also the technical like diagnostics coupled with labor. Okay, so how do you see that? How do you compare the robots versus the drones versus the geospatial techniques? Like now we are using the remote sensing images also. Well, those images are already available. People are doing the real-time monitoring using the satellite-based images, and some are using the drones. Now you are suggesting robots. First of all, how they compare technically and the cost-wise? How do they compare? And secondly, the robots is to be used in Indian land. Do you think the kind of land holdings we have, like small land holdings, do you see the application for the small and marginal farmers? These are the two questions.
Yeah. Thank you for those wonderful questions. Yeah, again, when we look at robotics, so we all start from the satellites, remote sensing, but that can give like a field level reading. So, but what we want would be going into final resolution with that precision agricultural technique that can actually bring a lot of savings to farmers. If you look at precision spraying techniques, they in the US actually they have brought down the cost to around 90-95% down. So so if you spray herbicide only on the weeds, we can actually make that saving, and also think of the environmental saving as well. Any fertilizer, nitrogen fertilizer that you apply more than what is necessary would go as runoff. So the environmental impact would be very high. The satellites can give only that farm level reading. Drones, they can bring, we can be much closer, but still there are challenges. But again, when you have to apply for precisely, you need to go there. The satellites and drones, they can give that initial picture, and then we can send, oh, these are the areas in the field that I want to address first, and then send.
Integrate the two things together.
Yeah, and again in the UK, so that is the first and question answer to the first question. And second part, even in the UK at the moment, most companies, they offer these technologies as a service rather than selling them to the farmers. So so robotics as a service, I showed you the company that doing that UVC treatment. They have around 200 robots operating at the moment, but they all are like a service. They say, okay, for this year, we will treat these fields. So they're doing in the UK and also in San Francisco, US, but as a service. So in Indian context, actually, it could be a corporate service or something. They can own these robots, and then farmers can, yeah.
All have custom hiring centers.
Yes, yeah.
So there we get there's one person, he buys the equipment and then the farmers. That's called custom hiring in India. That can be applied, so that's a good thing. And for the benefit of the students and the faculty, I would like to share here that together with Lincoln University, we have designed one course on robotics. Course has already been designed, 6 weeks. I think it's a 2 months course, or I don't remember now. 8 months is 8 weeks course.
6 weeks, I think. Yeah.
Course we have designed it, and we will be launching somewhere in July. We are working on that. So there's a, like, those who are interested can that's for the agriculture and horticulture both together, and food also. So these two together, and part of they will be going to the UK and studying about this thing along with a practical experience. So that's one development which we are I think we should be taking that further discussions we'll take forward, and we'll finalize before the July so that our students can be benefited by that. So thank you so much, Gautam, for being with us and sharing some of the glimpses of your work. I think this is not the real all what you are doing. You attuned your talk to our conference, so thank you for that. And I think in the course you will be teaching much more than what has been presented over here. Thank you so much. Yeah, over.
Thank you very much.
Thank you, Professor. Thank you very much once again. Now, if any questions from the audience, otherwise we proceed to the another. No questions? Okay, once again, thank you, Contribution. Now, our next speaker, Dr. Mukhtar is present. Oh.
Yeah.
Now, our next speaker, Dr.
Good afternoon.
Senior Researcher, Plant Genetic Resource and Arid Agriculture.
Jetzt kann ich die Frage nicht stellen.
So now, I like to give you this.
Good evening, Dr. Mukhtar. Dr. Mukhtar has the focus on the genetic diversity analysis, molecular and morphological characterization of crops, plant breeding strategies for adaptation to saline and climate-stressed environment. He published a number of papers in reputed journals and also serves as the reviewer for the scientific journals. Other than research, he teaches the subjects like plant breeding and crop improvement.
Thank you. Good afternoon. Thank you for the organization committee, for Dr. Nitan for this invitation. I am became Mukhtar from Institute of Arid Region. I want to speak today about the sustainable greenhouses vegetables production using geothermal heating and irrigation technology in south of Tunisia, south of Tunisia. So climatic change is increasingly discussed in the world, but in Tunisia is already a live reality. Increasing drought and irregular rainfall affect agriculture system sustainability. And as you see here, throughout the global map of country vulnerable to climatic change, we can note that paradoxically, the country least responsible for climatic change are the ones that suffer in its impact the most. It's the case of Tunisia, of course, and many other countries. The map of vulnerability to drought and salinity show that the area of arable land is greatly decreases due to climatic change, and the drought and salinity are the main environmental contrast. We can note that drought affect 1/3 of the Earth surface and salinity affect more than 6% of land and 30% of irrigated areas. In arid region are often affected by salinization. This case of Tunisia, where the Arab land decreased by 3% each year, which negatively affect biological balance, agriculture production, and the country's economy in general. That's why the strategic agriculture development in Tunisia is based in the sustainable management of natural resources like water resources, soil, and genetic resources, and of course to diversify on the diversification of agriculture production. It is to in target of to improve resilience and food security. In agriculture in south of Tunisia, arid region is based on oasis agriculture, which characterized by the association of many crops, data palms, fruit trees, and vegetable and cereals. But the increasing scarcity of surface water obliged us to use the water from the Sahara aquifer system, which shared by Algeria, Tunisia, and Libya, as showed here in the maps. Here is Tunisia, Algeria, and Libya, and there are more than million kilometers, square kilometers, this aquifer covered. It included the two big water sheets of the intercalaire continental and terminal complex. The water resources of these two aquifer were used in agriculture field, of course, and for irrigation of oases for the supply of to cities and industry, notably in the sector of oil and tourism. As this picture show, this hot geothermal water with temperature between 45 to 60 degree must be cold before used to the irrigation of oasis. But we can use it in the, it is possible to use it this geothermal energy for heating greenhouses for vegetable production like tomatoes in winter and in the region, arid region of Tunisia, of course. So by this opportunity, we have developed the geothermal greenhouses using the geothermal energy for greenhouses heating and greenhouses irrigated with geothermal water development alongside oasis system. So these greenhouses covered actually more than 270 hectares in south of Tunisia and produced more than around 40,000 tons by year. More than the half of this production is exported for European country and other market, international market. So, but of course, there are a challenge to the sustainability of this agriculture of crops under greenhouses, like salinization of water and soil, as shown here in this picture. The brown disease in the soil. And of course, the extreme climatic condition, high temperature, and strong winds. First, with this beauty and abiotic contrast, the sustainability of agriculture of greenhouses has been strengthened through the adoption of advanced agriculture practice, including, of course, the implementation of soilless cultivation system, the use of grafted plant on roots Scott resistant to disease and tolerant to salinity, and of course the desalinization of geothermic and sea water resources to enhance water availability and support the expansion of greenhouses cultivation. Several study has been conducted at our institute, Institute of Arid Region Institute, to optimize the application of this technical according to the local condition by integrated smart technology to support the development of greenhouses vegetable production in south of Tunisia. I want to present here an example that reflects the development of greenhouses vegetable production in south of Tunisia for the company Hisha Joe, which is a partner. We have a collaboration with them in order to improve the use of high technology in the condition of our region. So here, this is the Hisha Gel, and this is our institute, Institute of Arid Region in south of Tunisia. The Hisha Gel is disposed more than 6 greenhouses with 10 hectare each one. And why they are in Tunisia? Because of good climatic, ground condition, availability of energy resources, workforce, and short distance to the important market, international market. So the production take place in a modern glass greenhouses equipped with advanced technology, and the greenhouses climatic and irrigated are controlled through with automation system which manage climatic and irrigated irrigation. This automatic always prices crops string and consist quality. Water management is one of the core innovation at this company. Of course, it's near to the sea, so desalination plant is currently under construction for them, and is expected to be operational this year. Answer sustainability and reliable water supply through cutting edge seawater desalination technology, reverse osmosis. Optimize efficacy and scalability, starting now with 7,000 cubic meter by day, and expanding to the 11,000 cubic meter by day to meet future demands of this company in a greenhouse, which target to reach 120 hectares of greenhouses of crops under greenhouses. So this capacity will sufficient to cover the irrigation needs for of greenhouses production area. In a second phase, the desalination capacity will be expanded, as I said, to 15,000 cubic meter by day. This expansion will secure long-term water availability and support future greenhouses development. The desalination plant ensure water independence, of course, of the company, and reduce the pressure on natural fresh water, which are very lack in this arid region, and support the sustainability agriculture in water secures region. Under greenhouses, the crop is irrigated using precise drip irrigation system, allowing water and nutrient to be delivered directly to the root zone. High irrigation precision, no water wasted, better nutrient uptake, and optimal root zone control. So we work also on the choose of the best one substrate and the grafting compatibility between plant and rootstock variety and rootstock, of course, in this company and our institute. So in this company operated a closed loop irrigation system, which significantly improve water sustainability. This system allow to use of irrigation water, reduced water consumption, and minimal environment impact on this arid region. The drain collection, the excess of irrigation water is not wasted, but the system is included the collection of drain water from the slabs, and transport of storage to storage in the tanks like this, and treatment before reuse. This approach help optimize water use in arid region, and the treatment before use are of the collected drain water is done by UV disinfection, ultraviolet treatment, which ensure elimination of pathogen, prevention of disease transmission through irrigation, and safe recirculation of water. This technology help maintain plant health and biosecurity. So the substrate of cultivation tomato crop, which is the major crop produced in this company and in all the greenhouses in south of Tunisia. The tomato are grown on substrate system rather than the soil. This technical have many advantages. Precise control of root zone condition, conductivity, and pH, reduce soil disease risks, and improve fertigation management. The artificial intelligence of for crop management. In this company, the use of artificial intelligence tools to support greenhouses management. All technology is used for monitoring plant growth and crop development, predicting harvest volumes, and production planning, optimizing irrigation strategy, and supporting growth in marketing data driving decision. So I thank you very much for your attention, and if there are questions, I am ready to answer. Thank you.
Okay, thank you very much for your such excellent and insightful presentations. Your talk on sustainable greenhouse vegetable productions using geothermal heating and the irrigation technology is such a wonderful technology which you have highlighted, and innovative of energy efficient approaches towards the vegetable production. You have very clearly demonstrated how these integrations of the geothermal energy can significantly reduce the dependence of our conventional energy sources, which energy optimal is very much essential for the vegetable productions. So it is generally the concept behind the greenhouses technology. But in our case, in our Indian scenario, as the most of the farmers of our country are more in the open field condition, and as well as the geothermal technology, if we use our geothermal is a location-wise based technology we have over here. So what you feel that this technology, like geothermal heating system technology, is it feasible in case of the greenhouse condition also throughout the cropping season? And I like to mention of the season because in some of the season, this geothermal technology may not be happens to be good for the crop itself. When itself the temperature is more heated, the soil temperature, the root temperatures will be more in case of the greenhouse concept. So what do you feel about this? Can you highlight it? Your few ideas?
I don't hear well your question, but I think your question is about the use of geothermal water in order to heating the greenhouses.
Yeah, actually, like in the greenhouses, heating should be in the particular season only, no? Like if I feel that temperature below minus or below two, whatever maybe, in that location based, the greenhouse technology of your thermal is very much good. But if I consider with a very high temperature, generally in our Indian scenario, if you go for the greenhouse concept or the glass house concept also, inside will be the very high. I'm talking about the very medium cost of the greenhouses, not about the high-tech greenhouses. So in that sense, in medium cost technology of the greenhouses, in the summer season, what you feel that your geothermal heating system will be applicable?
Yeah, thank you for your question. I think that in south of Tunisia there are two types of use of geothermal water heating greenhouses. There are a big company with high technology where they can use this technology with a low cost. But for the young farmers, they use this geothermal energy for the heating of small greenhouses with a low cost, and but they can't use for a large area. The small project and the small greenhouses.
That you want to conclude that in case of geothermal technology in the greenhouses concept in the larger area is good. Otherwise, we can go for the conventional heating system, isn't it? As you talk about the small size of the greenhouses in the cold region also, then conventional heating systems will be more effective as per the cost of cultivations. I feel that conventional heating system is more efficient in your situation also. If the farmers are having the very small size of the glass houses or the poly houses compared to the geothermal, and because of the cost effective, isn't it?
I don't understand very well your question. I'm sorry.
He's asking that the geothermal technique is applicable for the large scale, but for a small scale, the conventional heating may be better. Is that correct?
Sorry, I don't understand very well. Sorry.
Thank you so much. Thank you.
Thank you, Dr. Mital.
Taking our invite and giving such beautiful presentation. Over to you, sir.
Okay, thank you, sir. Thank you very much for your presentation.
Thank you. I'm sorry for the.
Our last keynote speaker invited keynote speaker, Dr. Calvini, Professor Poole at University of Cagliari, Italy. So now I'd like to request Africa if the
Thank you.
introduction is part of Dr. Calvini.
Thank you, Kavali.
Good evening, Dr. Kavani. Dr. Kavani is the professor of food chemistry at University of Cagliari, Italy, and leads the high-resolution mass spectroscopy laboratory. His research focus on high-resolution mass spectroscopy, metabolomics, lipidomics, food and environmental analysis, toxicology, etc. He has about 160 publications, more than 4,000 citations, and H-index 35. He completed few national and international projects. Besides research contribution, he contributes to teaching, scientific evaluation, multivariate data analysis, method development, and applied metabolomics. Thank you, sir. I welcome you for your talk. Thank you, sir.
Thank you so much. Good afternoon.
Buongiorno, sir.
Just sharing my presentation.
Yes, sir.
You see it?
Yes, sir. Yes, sir. We are seeing your screen.
Oh, packet of my presentation. Okay. You see it?
Yes, it's very clear.
Because I don't see the presentation mode. Anyway, thank you, Nutan, for this invitation. It's really much appreciated to meet you again. It's very nice to see friends again. So today my presentation will be on the development of a new model, microneedle model for the field determination of cannabidiol in fresh cannabis sativa. But I don't see my presentation in the present mode. You still see me, right?
Yes, sir, but your screen is not in full.
Let me try again.
It's okay, sir. You can start with this. No.
Okay. Background of my presentation, in the framework and the European project, we were interested in looking at different chemotypes of cannabis. And as you know, there are three types of chemotypes. The one with high level of the psychoactive delta-9 tetrahydrocannabinol, and one with high level of cannabidiol that is not psychoactive, and another chemotype is 1-to-1 ratio of THC and CBD. In Italy, as in Europe, also in India, cannabis sativa is widely cultivated by growers for and production. And recently, cannabis production is increasing because of the ability of the extraction of cannabidiol for applications such as nutraceuticals, pharmaceutical, cosmetics, and recently as a novel food. The FCA, the European Food Safety Authority, is checking the toxicity of cannabidiol is also targeting this topic on at European level. So what we did, the needs of these growers is to accurate measuring cannabinoids on field, and this is very important for quality and regulatory compliance. In India, the regulatory framework and the industrial AMP must contain THC level below 0.3. In Europe, these values are comprised by 0.2 and 0.6%. And as I told you before, CBD-rich products are regulated today as a novel food. So there is a need to overcome traditional analytical methods that require extensive laboratory times to measure cannabinoid levels in the AMP products. So we need to a rapid field analysis of these cannabinoids, and we also need something that is available, very easy, rapid, and not destructive in field. So the need is to measure the level of cannabinoids without destroying the samples. Actually, the methods and the conventional technique that are used for detecting cannabidiol and tetrahydrocannabinol are gas chromatography methods or high performance liquid chromatography methods. But those methods, as I'll show you later, require time consuming steps for sample processing. So the aim of this study was to develop, at the same time validate, a portable microneedle spectroscopy model to measure in the field on fresh samples the level of cannabinoids. Keep in mind that already exists validated methods for measuring cannabinoids, but only for dried samples or using chemical device. They are very expensive. So we decided to develop and validate this method using the near-infrared spectroscopy, and using those models, we were able to measure cannabinoids on fresh samples. We were able to analyze almost 2,000 AMP inflorescence. So we had, in the framework of this European project, different growing sites, and we cultivated different cultivars, such as an Nectariana and Nectarol, with different level of the expression of cannabidiol. And samples were collected from the field and taken right away to the laboratory for the measurement of cannabidiol and other cannabinoids. So this is how we proceed. We first did the spectral acquisition using an handheld microneedle spectrometer. We just look at, with a few seconds measurement of the inflorescence, we measure the level of cannabinoids. And the advantage of using an handheld microneedle spectrometer is the rapid, non-destructive, and minimal sample handling of samples. So once we acquire all the samples by the NIR system, we needed a reference analysis. This reference analysis is done by the quantitation and quantification of cannabinoids using gas chromatography with flame ionization detector. And this is the reference analysis that is used commonly in the laboratory for measuring cannabinoids. And this measurement gave an accurate reference values and allow us to calibrate the our spectroscopic model. Once we had this reference model, we built the chemometric model, and this model allow us to pre-process our data. We then transform with the first derivative our data, and we reduce the noise with the standard normal variated steps. This is done to reduce baseline shift, to correct the scattering effect during sample acquisition, of course, during the acquisition of fresh plant tissues, and this is why we correct our data. And finally, we develop a partial least square regression model that allow us to build this this model. And the model performance are really predictive with standard with the statistical values of the optimized model very strong, with a strong correlation between predicted and reference cannabidiol values measured in the laboratory and measured in field. I don't know if you probably cannot see the slide, but the accordance between the two measures in the field and the laboratory is really close. By our model, we were able to measure levels of 7.39% of CBD by our microneedle model, while in the laboratory we obtain value of 8.15% of cannabidiol. So very strong correlation between predicted and reference CBD values, and this is very nice for the implication for smart farming, because you can use microneedle technology to for the rapid cannabinoid monitoring in the field on fresh sample for the first time. So you can do real-time field analysis on each plant. Before was almost impossible. I can check the quality of my crop actually on any plants by monitoring cannabinoid levels during growing stages. I can also improve crop management, knowing the real concentration of cannabinoid in every moment, and so I can have a faster quality control system to predict also the levels of CBD. Potential application of this model are breeding programs, of course. Harvest optimization, I can decide to harvest at a particular moment when the levels of cannabinoid are really high, and also potential application are regulatory compliance checks, because the police comes to the field and check which chemotype are you using, which seeds are you using, and need to know if the plants are compliance with the actual regulatory system. So in conclusion of my brief presentation, we develop a portable micro-handed near spectroscopy method for measuring cannabidiol and cannabinoids in inflorescence. And this method is very rapid, 3 seconds, 4 seconds, non-destructive, and suitable for field condition on fresh sample. The developed partial square model show a very good predictive method, so they can be easily used by the growers. And in our opinion, microneedle technology represents a very promising tool for digital horticulture and smart farming application. My last slide, I would like to acknowledge all the people working on this project, Dr. Mattia Casula, Dr. Andrea De Serra, Professor Pietro Rogero, Nicola Ragazzo, and of course the European project Canapa Innovation Hub Cultivat from 2023 to 2025. Thank you very much for your attention. I will be very happy to answer your question.
Thank you very much, Dr. Kaumani. Your presentations has opened a very new areas of spiritual acquisitions in case of the cannabis. You have a very effectively demonstrated how chemometric model works, as well as your implication of smart farming in the cannabis is wonderful. Your work really development of the micro-NR model for infer determination of the cannabis price, which represent a very much significant advancement in the present scenario of the precision horticulture and the real-time required for the crop-based analysis. So such a wonderful presentation you have highlighted. Thanks for the from our inner heart, as well as the thanks for the organizer. And one question which I want to ask you is that as you're talking about the MRI technology, what level of the accuracy you can observe in case of the laboratory method or at the time of the field condition also?
The level of accuracy is very high. Go back to the presentation. Level of accuracy is 0.82 as a root square and a Raman sec of 0.70 with a bias of 1.0 with the 0.0001. So this is this value, this optimized statistical data really have a really strong correlation between predicted and measure levels of cannabinoids in the samples in the laboratory. We compare what we measure. Actually, the first step was to build the model, and then we develop. We try the model. We check the model if it was working well with a known sample, and the model was able to strong correlate between the measurement in laboratory and measurement of the model.
Yeah, on the basis of the sample, what you are using, I think so.
Yeah.
Thank you very much, Dr. Caravelli, for your nice presentations.
Thank you very much.
You want to have one questions? And give a thanks to Dr. Company.
Thank you, Kabodi. It was a wonderful presentation. I think I saw you have developed an NIR-based probe which can detect the real-time cannabis content. Is that true?
Yeah.
And that probe is using the leaf or sensing or the whole plant, or like how does it sense? Like
only on the fluorescence, only on the flower.
Only the flower.
So yeah, because the flower contains the cannabinoids.
Okay.
Only the flower contains the cannabinoids.
Okay. And so is it available? This particular model is available in the market or is still under the development?
It's available only on the dried samples. So you should take your sample to the laboratory, dry it. It takes 2 to 5 days. Okay. But we develop a model, and it's our property, our intellectual property, on a fresh sample. So you can measure on the plant, directly on the plant.
Directly on the plant.
Yes.
So apart from cannabinoids, have you applied this technique for other contents also? Some other metabolites also?
Yeah, if they produce cannabinoids, yeah, you can develop a model on the chemicals that you want. Yes.
Thank you.
Very nice, because you can. It's a portable system. It's like long like this, 10 centimeters, and you just measure the level on each plant. It's unbelievable.
Thank you so much, and sorry for making you wait for such a long time. So thank you.
No problem. Thank you, Nutan. It's a very pleasure to meet you again.
Maybe see you in November.
Maybe next time. Perfect. Thank you very much.
Thank you very much, sir. Now we have covered the keynote speaker on this session. Now we'd like to start with our oral presentation of the rapid fire presentation. So I'd like to call upon the number one, Silpa. Silpa, your presentations will be in development of the smart hydroponic management system, integrating IoT and machine learning for growth predictions in greenhouse. They're giving 5 minutes and 3 minutes.
Very good evening, everyone. Myself, Shilpa S., PhD scholar from Indian Agriculture Research Institute, New Delhi. Today, I'm going to give my oral presentation on the topic of development of the smart hydroponic management system, integrating the IoT and machine learning for crop growth prediction in the greenhouse environment. As we know that agriculture is evolving from the traditional labor-intensive farming to the smart modern agriculture with including agriculture 4.0 and agriculture 5.0, where the technologies like IoT, AI, and automation are being used. And still, we are facing the challenges: food security, resource scarcity, and the climate variability. So, it is necessary to adopt the advanced technologies like soilless cultivation to grow the plants. It has the key advantages like it will save the water, 95% of water use efficiency, and it saves the space by 65%, and it will also increase the air productivity 4 times higher than the conventional farming. Our study was conducted in the Smart Vertical Hydroponic Greenhouse at the CPCT ICRAHOR in New Delhi. In this study, we evaluated the effect of different growing structure, nutrient solution, and the different growing media on the plant growth. Especially, 2 types of structures were used, such as A-frame structure and flat bed, and 2 types of nutrient solution, whole gland and the CPCT solution, and 2 types of growing media, such as clay balls and the rock pools were used. Among these all combination, total 8 treatments with the 3 replication with the completely randomized design was designed, and IoT based fertigation system was developed for the automation. In the first step, hardware components such as water quality sensors such as EC, pH, water temperature, and the microclimate sensors such as temperature, relative humidity were installed for the real-time monitoring and the automation. And the software components like ESP32 microcontroller was programmed using the Arduino and the C++ program for this to read the sensor data and the control the system. And in third step, all these collected data was automatically uploaded to cloud platform like ThinkSpeak, where we can store the data. This is the framework of my framework where the different machine learning algorithms are used to crop growth prediction. First column is showing all the input parameters we collected through the sensors and other instruments. This all the data was pre-processed to remove the outliers and the handling the missing data and to normalize the data. And we divided the data set into 2 sets: training and testing data, 70% for training and 30% for the testing. And the 7 models were used. All these models were trained using all the input parameters, and that models were evaluated and tested using the evaluation metrics like mean absolute error, mean absolute percentage error, root mean square error to predict the plant growth. And these are the result we got. These all scatter plots are showing the performance of all the machine learning models, where we got the random forest as the highest accuracy with the R-square value of 0.98 and with low mean square values, low error values. And in case of dry weight also, we got both KNN and random forest was the highest accuracy with the 0.98. And in case of plant 8 also, we got random forest as the highest accuracy with the 0.924. And the root length case also, we got the random forest and the KNN as the best models. And in case of number of leaves also, random forest we got the highest accuracy, performed the better with the 0.864 R square value. And in leaf area, both KNN and the random forest performed the better. And for chlorophyll content also, random forest and KNN performed the better with highest accuracy of 0.86. I would like to conclude my presentation with the outcomes that we developed the IoT-based hydroponic system and all the 8 treatments. We got the customized treatment 3 as such as combination of customized CPCT solution and with apron structure and labels with the highest accuracy, and the random forest model as the best model among the all machine learning models used. Thank you.
Okay. Thank you, Shilpa, very much. Your presentations are nice. Just I want to ask one question regarding you, as because you have developed some of the smart hydroponic management system, and you are observing the crop growth in the plant which is present in the greenhouses. But which plant? Because you have shown some of the root length, some of the characteristics.
Yes,
but of which plant?
Lettuce plant we use it.
Even in your mathematical, you have mentioned the plant. Your main focus is only for the development of the system. But as per this development of this system, your plant is also one of the major factors. Isn't it? Without the plant observations, you can't develop your this hydroponic setup itself.
Yes.
So don't neglect the plant also.
Okay, sir. Thank you.
Thank you.
Thank you, sir.
Next. Bharat.
One second one. Very good evening to the respected judges and judges and all the audience. Myself, Bharat. I'm from Indian Agriculture Research Institute, working under Dr. Murtaza Hassan, principal scientist. So today I'm here to present my topic: AI and IoT enabled smart vertical aquaponic system for real-time nutrient dynamics and growth optimization. So we know that the urban population is increasing day by day. By 2050, it is estimated that 70% of the urban population will live in urban areas, and we are using in our country 70% of the fresh water sources for irrigation. So there is a critical gap, and aquaponics, we know that the combination of the cultivation of both fishes and crop at the same unit. The objective of this study is to evaluate the AI and IoT enabled vertical aquaponic system for real-time and predictive nutrient management. So this is the polyhouse facility at our IRI New Delhi. The materials methods, this is the AI and IoT smart aquaponics integrated framework. Our system has five layers. The physical layers contains the recirculating fish tank, biofilter, the NFT, vertical NFT. The crop selected for this study is pokchai and lettuce. The fish is Channa strata fish, that is known as snakehead fish. In the sensors layer, we use DO, pH, EC, nitrate, ammonia, and nitrite sensors. And other weather monitoring sensors are also used, and data logging is for 30 seconds. And the gateway is Raspberry Pi4B, and AI analytics. Here we used hybrid model of CNN and LSTM model. So based on this model, the TAN, that is total ammonia nitrogen, it is detected. So this is our exact system architecture, the developed system. We can see the fish tank. The water from the fish tank will be pumped into the filter so that it will remove the solid particle or waste from the fish. Then again, it will go to biofilter where the conversion of ammonia to nitrate happen. Then the water is transferred to the nitrate rich water will be transferred to the NFT layer where the plant utilize that nitrogen and they will grow. So these are the various sensors used, and this is the IoT based
real-time monitoring dashboard. So this is our core of the system, CNN LSTM deep learning model. So here CNN layers and LSTM model is used for prediction of tan toxicity. So that will tan toxicity will affect the fishes. So it will affect the health, especially gills of the fishes. This is the IoT based real time weather and water quality monitoring. That is, the screenshot of ThinkSpeak, the real time data. Coming to result, we took two treatment. One is IoT enabled aquaponics, and another one is conventional aquaponics without IoT. So we seen the fresh weight of the pokchai and lettuce. You can see the graph. We are seeing like the more increase in yield we are seeing, and again in chlorophyll content also we observed the more chlorophyll content in the IoT model and the higher leaf number also. So coming to plant nutrient, we did nutritional analysis also. We found more vitamin C, potassium, and again crude protein content we due to good maintenance of the system in IoT system. And again, this is the aquaponics. As much as crop important, the fish performance is also important, because we are seeing the both the component. So we are seeing that in 18 weeks, this research was taken in 18 weeks. So the fishes were reached up to 620 grams. But in case of conventional aquaponics, it is about 450 grams. So it is due to stress-free environment. This is regarding to the nutrient use efficiency. We observed 84.7% of nitrogen use efficiency, 71.3% of potential phosphorus retention, and again other chemicals also. And nutrient cycling efficiency, nitrification efficiency 98.2. That means the whole ammonia produced by the fish is converted into nitrate within the 24 hours, about 98%, 2%. So this is regarding to water and energy resources. We can see just with the 6 liter of water, we produce 1 kg of produce in AI and IoT enabled aquaponics unit. We can see in open field, it is about 285 liters. And even energy distribution in the system, the major energy utilized for pumps and lighting. This is the various water quality dynamics in IoT and AI-enabled aquaponics system. So this is the optimal range collected from the various researchers. Our system is maintained over the 18 weeks. Our system is maintained within the optimal limit. So to conclude my research, 93.8% CNN LSTM tan toxicity prediction accuracy was recorded. 44% of the reduction in fish mortality rate, and 93.2% water saving versus open field agriculture, and 41% of yield increase in yield is observed. So these are all the reference, and I got 2 patents for this my research. So this is the Union Minister of Agriculture personally visited my research, and thank you for the opportunity.
It's a nice presentation, Bharat. Thank you very much. You have developed the aquaponics systems very well comparison with the IoT and the traditional method. Okay. Now, one thing which I want to highlight it, and I want to suggest you, like, unnecessarily why you are observing the quality parameters. If you want to observe the quality parameters, we have to observe the quality matters which will be the beneficial. In case of the pathway and the lettuce, vitamin C is not a matter. If you want to go for the lettuce and the pathway, it is better to go for the observation of the quality matters like vitamins A. Yes. Okay. And the thing is that yeah, I've seen so many papers, even the organic concept also. In the real practically, there is no such type of the variation in the quality. Say for example, organically grown vegetables and the vegetables which are grown in the inorganic also, there might be the appearance will be the different. The quality wise is the physical appearance of the quality will be different, but there will be never the quality parameters of the biochemical analysis. In the same case, you are in IoT, your comparison with the IoT as well as the conventional method of growing up these plants, there is no variation of the quality. Practical, you see yourself also. I've did a lot of research in this. No, always there is a variation of the quality of the physical parameters quality, but not the biochemical analysis quality. So that is the wrong thing, wrong conception, which you are highlighting everywhere. Most of the researchers think like organically grown vegetables will give the more vitamin C. No, not like that. Same cases happens in US also.
Sir, the only thing I want to tell is like in I know in non-IoT method, the mortality of the fishes are more.
Quality of the plants.
Due to mortality, there is a less nutrient supply to the plants. So it goes.
You do your experience very seriously. And which analysis, what type of analysis in which method?
Sir, protein analysis.
Because you have shown the vitamins. Which method?
Sir, vitamin C, actually we did, I don't know exactly.
And the most of the time,
NIFTIM actually, sir.
estimated using a spectrophotometer.
Yeah.
And a spectrophotometer is not reliable.
Actually, sir,
not a reliable. This is a very this is problem with the horticulturists also. If they want to do the biochemical, but the estimation is not done in the right manner. The estimation is not done in the right manner. So anyway,
Okay,
doesn't
sir.
matter. The yield is important. Okay, yield is important. The cost effectiveness is another important parameter. If you can tackle that also, so there's
Okay,
no
sir.
need to highlight that everything is
Nutrition.
biochemically superior. That's what the Dr. Thapar did.
Sure.
There's no need to prove the biochemical superiority. There's only need to prove that yes, the yield is improved, the cost is improved, effective biomass is improved, and the use of energy or whatever the nutrient uses, water use efficiency, nutrient use efficiency, these are important parameters. Okay,
Sure.
so just focus on that one.
Okay, ma'am.
Unnecessarily don't focus on the biochemical part, which is not estimated accurately.
Thank you, sir. Thank you, ma'am.
Thank you so much.
Next, Vinod Kumar. Next, Akif.
Sir, we have one offline program, do you know? Okay, so for regarding the sir, Dr. Thapas's time is moving very. We are 7:15 already, so we're thinking that online presentation, if we can move toward tomorrow with the online poster presentation.
And physically there is one Arnav Kumar. And Kumar.
So is there any more physical?
Any more physically?
Offline, anyone?
Offline anyone? No one is offline.
No one is offline. So Abhishek, so tomorrow along with the online posters, you could club these online oral presentations. Okay. So just inform everybody, Dr. Arpita, that and share the link also, appropriate link, because that link is different. Online poster link is different. Just announce that.
There is an
No, the
announcement
link is
for
also
these.
different.
Student
Time is
poster-
also 1 p.m. tomorrow, lunchtime.
So those who have joined today for the online presentation, so it is those who have joined today for the online presentation for this session. So due to the time, it is not possible to conduct right now. So tomorrow it will be held at 1 p.m. and separate link will be sent to you. Okay, those I think three presenters are present today. So we'll send the link for tomorrow, and it will be available tomorrow at 1 p.m. Yeah. Now I request Nutan Kaushik ma'am to felicitate our today's session here.
Good evening, everyone. As we conclude this enriching session on digital horticulture and smart farming, I would like to extend my sincere gratitude to all who contributed in this successful event. First and foremost, I will like to express my heartfelt thanks to esteemed session chair, Dr. Umesh Thapa, for his insightful remark and for the session chair, as well as in clarity and expertise what he has provided. I would like to convey my deep appreciation to our keynote speakers, Dr. Christine Liss, for his excellent talk on the role of plant resilience in sustainable horticulture, which provide important perspective on resilience-driven crop improvement. I would also like to thank Dr. Gautam Das for his engaging presentation on robotics and AI for improving resource efficiency in agriculture, highlighting the practical advancement in agro-robotics and intelligent systems. My sincere thanks to our invited speaker, Dr. Mukhtar, for his informative talk on sustainable greenhouse vegetable production using geothermal heating and irrigation technologies in southern Tunisia, demonstrating the regional specific sustainable solutions. And also, I would like to thank Dr. Kaboni for his insightful presentation on development of micro NIR model for in-field determination of cannabinoidal fresh cannabis sativa inflorescence, contributing to the precision and analytical advancement in the horticulture. So we will continue the session tomorrow. Okay, that's all from my side, and we'll continue tomorrow.
With this, we come to the end of day 1 of ICRAHOR 2026. Tomorrow, we shall continue with session 3, 4, and 5, covering key themes in post-harvest management, climate resilient and urban horticulture, horti entrepreneurship, success story session, followed by award distribution and the valedictory session. We look forward to your presence tomorrow. Thank you one and all, and have a pleasant evening. Jai Hind, Jai Kisan.